Hey guys, so today we are going to discuss. No. Today we're not going to discuss anything. Today we are going to solve top 100 lead code like questions. Yes, today we are going to solve this top 100 lead code like questions. So in lead code we'll be having few problem sets, right? So here we have top interview questions, top 100 like questions, similarly top Facebook questions, top Google questions, etc. Right? So as we don't have access for these because it requires premium, right? Because we're not that rich, so I'm going to solve which are having access. So in this case, there are two problem sets which are top interview questions and top 100 liked questions. So I thought of picking up top 100 liked questions. So the reason why I'm trying to do this is, I have a bit of DSA knowledge before, but I want to brush them up back. It's been a gap, it's been a lot of time that I have got into these DSA things, right? So I thought of brushing up these skills back again. So I felt, taking up this 100 lead code like questions would be a best way to brush up these skills and get back to the form. So I thought of taking up this challenge of solving top 100 lead code like questions. So yeah, so this contains multiple difficulty level questions. So as you can see here, it contains easy, medium and hard. So there are like easy are like let me filter that. So not many, maybe less than 50 as well. And coming to medium, so medium, let me filter. So yeah, so there are many, 2 pages. So there are 2 pages of medium questions. And coming to the hard question, this is a tricky part. So hard are not many, but still hard questions have difficulty level higher when compared to medium and easy, right? So it might take some time. So yeah, so these are the questions. So combinedly there are of 100 questions, right? So combinedly there are of 100 questions. So I'll start with easy questions because it would be like a warm up for me, right? So instead of going right to the hard question, it would be easy to ramp up with these easy questions, right? So yeah, and coming to the main part, I may take or may not take the help. I don't know because it depends on the situation, right? It depends on the question which I'm going to solve. It depends on the situation where I will be, right? I don't know whether I'm going to take help or not. But maximum, I'll try to take not take any help from any external sources or like that. So yeah, so I have a timer and I have a counter here. You can see in the top right corner, right? So I have a timer, so which is going to start whenever I start. So it's going to show us how much time it has been till now. So there is another thing called as solved. It's going to show the number of questions I have solved until that point. So I'm going to increment that every time I'll be solving a question, and along with that, at the beginning I'll be starting the timer, so we don't have to do that again. So all we have to take care of is this solved section. I have to increment each and every time after I complete a question, because we cannot automate that. There might be, but I don't know how to do. So yeah, so let's start the timer. So let me start with these easy questions. Okay, let's start with the easy questions. It would be like a warm up. So here we go. Yeah, timer is running. So let me filter this with some easy to hard. In the easy, again in the easy to hard. So let's go with the first four. I want to make this a fast, like a speed run. I don't want to do like go to my and I want to do. If it is fruitful is possible, then I would try to solve with fruitful only. I think you got my point. It's not for discussion, it's just for solving. So yeah, maximum depth of a binary tree. Given the root of a binary tree, return its maximum depth. So what is a depth? So in this case, it's 3. So okay, we have to find the maximum nodes. Got it. So this is like a post order, I guess. So I'll do DFS. It's not DFS, but I don't know why I use DFS as a method name. So if root is equal to null, return 0, or else I'll get the left depth by going towards the left, and int right, I'll get the right side depth while going towards the right. And I'm gonna take int, answer is going to be math.max of left and right and +1. So I'm going to return answer. I think this has to work. Maybe I can just do this. Return. I can remove this. Just try to return GFS root. Let's see if this works. Let's use some example test cases. Yeah, let's try to submit this. Yeah, it got succeeded. Cool. Oh, I forgot to increment the pointer. Okay. Yeah, I think you can see it now. So yeah, so given the root of a binary tree, note the tree and returns root. What is okay? Inversion is swapping. Okay, swapping is easy. So public void. Maybe I'll just use DFS again. Root or root, and if root is equal to null, return, and DFS root dot left, DFS root dot right. Now tree node temp is equal to root dot left, root dot left is gonna be root dot right, root dot right is gonna be temp, and it's gonna return. At the end, I'll just call the root and return root. This has to work. Let's see. Let's try to submit this. Yeah, cool. Let's increment the pointer. Okay, cool. It's okay. A binary tree node traversal. So this is a pretty straightforward. There are multiple approaches for this, like more is node traversal, but as I said, I'll be using a fastest way. So void, again the method name dfs root. So if root is equal to null, return. So in order is something going left, coming back to root, right? So dfs root dot left. Now answer dot add root dot value and go right. This has to work. So list integer answer list. So dfs root return answer. Let's see if this works. Cool. So yeah, let's try to submit this. Yeah, it worked. Reverse a linked list. So this is a standard problem. This is a standard problem. List node preview, list node. I'll be taking 2 pointers, preview and next. So while head is not equal to null, next is gonna be head dot next. Head dot next is gonna be preview. Preview is gonna be head, and head is gonna be next. Yeah. So now head is gonna be preview, return head. This has to work. Let's see. Yeah, let's try to submit this. Let's go back. How many have we done? Okay, cool. It worked. Oh, I forgot to increment the pointer twice. So we are done with 4, right? Let's try to refresh this once. Come on, come on. Okay, 4. 1, 2. Yeah. Okay, so next 4 questions. 1, 2, 3, 4. That is. Let's remove that. Leetcode.com problem single number. Why is it taking a lot of time to load? I don't know why. Okay, single number given to one appears twice except one. Okay, this is XOR. Okay, int XOR for int value nums XOR of is equal to val return XOR. I guess this has to work. Okay, submit. Given an array of it worked. So given array of num size and majority which appears more than n by 2. Maybe I can do the hash map. I can use hash map integer and its frequency, maybe like a map hash map, and I'm going to iterate for int value from nums. So map dot put value, map dot get or default value, or default is 0 plus 1. So I'm going to iterate to the map and integer and m map dot get entry set, right? So int value is going to be m dot get key, int frequency is going to be m dot get value. So if frequency is greater than n by 2, right, that's the requirement. So return value, return -1 maybe, because it says always a value exists, so it doesn't come to this place, but still we have to return something. So I'm going to create a variable int n is going to be nums dot length. So yeah, I guess this works. Let's try to see run this once. Okay, let's use some extra test case. Okay, yeah, let's try to submit this. Merge to sorted lists. Okay, this worked. Okay, you're given a heads of two sorted lists, list 1, list 2. Merge two sorted lists in one sorted list. The list should be made by, okay, so what I'll be doing is maybe I'll create a dummy node initially, some random value, and while list 1 is not equal to null and list 2 is not equal to null, what I'm going to do is, if list 1 dot value is less than or equal to list 2 dot value, dummy, okay, I'll use a pointer as well for attaching the nodes. ptr is essentially it's going to point dummy. So ptr dot next is going to be list 1, ptr is going to be ptr dot next, else ptr dot next is going to be list 2, ptr is equal to ptr dot next. So yeah, I think you can actually make this here, no need to use twice. So yeah, so this is it, I guess. No, there might be some remaining leftover ones as well, right? So if list 1 is not equal to null, ptr dot next is going to be list 1. If list 2 is not equal to null, ptr dot next is going to be list 2. Return dummy dot next. Let's see if this works. Time limit exceed. Okay, yeah, I got it, because we are looping, right? We have to move the list 1 pointers. So list 2 is called list 2 dot next. These have to be list 1. Let's see now. Oh yeah, it worked. Let's try to use some extra test case. Okay, run it. Okay, let's try to submit this. Yeah, it worked. Let's go to the next question. Move zeros given an integer array nums, move all zeros to the end of it while maintaining the relative order. Okay, this is like we can use a 2 pointer. Left is going to be 0, int right is going to be 0, while right is less than nums dot length. What I'm going to do is, if nums of right is not equal to 0, nums of left is going to be nums of right and left plus plus, else, or else I can just do right plus plus. So then while left is less than nums dot length, nums of left is gonna be 0. I think this works. Let's try to do this once. Okay, time limit exceed, I guess. Yeah, so why? Okay, I have to increment this left pointer. I forget to increment pointers sometimes. Yeah, let's use some extra test cases. Okay, let's try to submit this. And we forgot to increment our solved point counter as well. Yeah, so we are done with 4 now. Let's increment 4. 1, 2, 3, 4. So 8 questions total. Let's try to refresh this. um okay, 4, 8 done. So diameter, best time, buy and sell stock, symmetric tree, and intersection. Okay, didn't go wrong. Okay, diameter of, okay, binary tree. So given the root of binary tree, return the length of diameter. So what is the diameter? Length of longest path between two nodes. Okay, got it. This is just finding the max of left. I mean, just finding summation of the left and right and returning the max. So in DFS again, I mean the method name is DFS. Tree node root. If root is equal to null, return 0. I'm gonna get the left. DFS root dot left int right. DFS root dot right. So I'm gonna find um the max, right? So in this case the max is 3. Okay, so answer is gonna be math dot max of left, I mean answer and left plus right, and return math dot max of left comma right plus 1. I'm gonna use answer variable. Initially it's gonna be 0, anyhow its default value is also 0. So let's return, I mean do DFS root return answer. I guess this works. Let's see. Okay, it worked. Let's try to submit this. Yeah, it got succeeded. Let's go to the next question. So given an array of array prices where price of I is the prices of the given stock, you want to maximize the profit by choosing the single day. Okay, so return the maximum profit you can achieve from the transaction. If you cannot achieve any profit, okay, return 0. So this is like a single traversal. Like I can just do minimum, can take a minimum variable which is going to be max at the beginning and max to keep track of max one. For int value prices, what I'm going to do is mean will become math dot mean of mean and value. So for getting the mean, I'll have to get the maximum profit, right? So that max will become math dot max of max and value minus the mean one, right? I think you got it. So return max. I think this has to work. Okay, let's try to submit this. Yeah, cool. I think we are done with two questions, right? So 1, 2. I have implemented the pointer, I mean counter. Symmetric tree, given the root of a binary tree, check whether it is a mirror of itself. So yeah, I got this question. So this is something very symmetric. Yeah. So I'm gonna take a boolean, gain the DFS tree node and root, because I'm gonna take the left and right subtree. So return DFS root dot left, root dot right, and I'm gonna do DFS root dot right comma root dot left. Both have to be symmetric. So root 1 3 node root 2. How much time it has been? Okay, 15 minutes. Too slow, man. Come on. Okay, so if root 1 is equal to null and root 2 is equal to null, return true. If root 1 is equal to null, return false. If root 2 is equal to null, return false. If root 1 dot value is not equal to root 2 dot value, return false. Or else what I'm going to do, return DFS root 1 dot left, root 2 dot right, and DFS root 1 dot right comma root 2 dot left. This has to work. Let's see these ones. Okay, let's use some extra test case. Let's see. Okay, let's try to submit this once. I'm actually doubting this a bit, but let's see. Oh, it worked. Cool. Okay, so let's increment the counter. Okay, intersection of two linker lists. I think I have done this before. There are two ways. One is using hash set, one is using finding the lengths, and that's one approach. So I'm gonna take the faster one, which is a hash set one. So a list node set new hash set. Right. So what I'm gonna do is a list node current head a, while current is not equal to null, set dot add current, and current will become current dot next. Similarly, current is equal to head b, while current is not oh shit equal to null if set dot contains of current, return current or true, right? Or current, right? Or else current is equal to current dot next, or else at the end return null, right? Yeah, return maybe return null. I'll return some null. Let's run this once. Whew. Okay, let's submit this. Oh yeah, it worked. Let's increment the counter. Okay, so yeah, we are done with 12 questions. Let's try to refresh. Let's see whether our counter is equal to the number of questions solved in here. Oh, 0. Oh, okay, it's still include. Okay, 12. So how many have we left? 1 2 3 4 5 6 6 more. Okay, let's take all of these. Let's okay, value parenthesis. Lot of time. I think I have to decrement this time late because of this loading time itself. Okay, given a string is contain, okay, determine this value. Okay, so this is like a stack. Evaluating something expression in, so we have to use stack. That's it. So character. So stack. Maybe I use st new stack. Right. So for each char from s, if c is equal to maybe an open one, and st dot size stack size greater than 0, and st dot ping top is equal to the open one, pop it out. Else if c is equal to, the conditions are similar actually, so it's if it is an open rectangular and size is greater than 0, and st dot peak is equal to the closed rectangular open rectangular st dot pop, and oh, it has to be a semicolon. Shit. Yeah. Else if c is equal to an open circular, I mean curly, and st dot size is greater than 0, and st dot peak is equal to, oh, this has to be an open one, sorry, I mean the closed one, close curly, and this has to be is equal to an open curly, then st dot pop, else st dot push c, and then return st dot size is equal to 0. I think this is it. Let's try to run this. My throat already started to get dry. Okay, let's see. Okay, cool, it got succeeded. Let's go to the next question. I think incrementing a pointer. Yeah, so search insert position, given a sorted array of distinct integers and target value, return the index the target is found. If not, return the index where it has to be. Okay, so login. Okay, you must write in log. So whenever they ask to write something in login, then they're expecting a binary search for sure. Okay, so it is there. Okay, Okay, let's first do for the case where element is there. So int left is gonna be 0, int right is gonna be nums dot length minus 1. For safety, let's use a variable, or else I have to again keep on using the same nums dot length minus 1 every time. So yeah, let's name it n, let's make it nums dot length. So now while l is less than or equal to r, int mid is gonna be l plus r by 2. And next, if nums of mid is equal to target, return mid. Else if target is greater than nums of I, go towards the right, which actually means L is equal to mid plus 1, else R is equal to mid minus 1. So in this case 2 is not there, so this 0 1 2 3 3. Okay, 0 plus 0 1. Okay, this incrementing L plus 1, I guess this is it. This works, I guess. Let's see, I think it's L plus 1 only. Yeah, return mid. Okay, nums of I, nums of mid, sorry, this has to be nums of mid. Any more? Okay, it worked. Let's try to see some extra test cases. Man, I can't afford it, got a premium. Okay, wrong answer. Nice. So 2 2 1 4 2 5. Okay, so let's try to print system.out.print ln l and r. Now let's see what are the cases. Okay, we are running 3 test cases, but why? Okay, one is taking. Okay, the answer required is, okay, we have to return not l plus 1, it's gonna be r plus 1. I think now it works. Come on, yeah, let's try to submit this. Okay, cool. Let's try to increment the pointer. Let's go to the next question. Linked list cycle. So this is also a famous question. I have done this before, but let's. There are two ways. One is a 2-pointer rabbit and hare, not tortoise and hare, sorry, and another one is hash set. So let's use the rabbit and hare one. That makes it faster. Fast head, list node slow head, while fast is not equal to null and fast dot next is not equal to null, slow is equal to slow dot next, fast is equal to fast dot next. If slow is equal to fast, return true or return false. I guess this works. I have to improve my speed, typing speed. Okay. Oh, this should be fast. Let's see. Okay, let's try to submit this. Probably this works. Okay, it worked. Let's go to the next question and increment our counter. Okay, given a head of singly linked list, return true if it is palindrome. Okay, so 1 2 2. So okay, so I can divide this half of the linked list and reverse the other half and just see both are equal. So first of all, I'll implement this reverse function. It makes faster. So reverse. So it's the same method again. List node, and it's gonna be next, which is null initially. List load preview, it's gonna be null initially, and while head is not equal to null, and now Come on. Okay, next becomes head dot next. Head dot next becomes preview. Preview becomes head, and head becomes next, and head becomes preview, and return head. I think this is the reverse function. So now we have to find the length, right? So the length, and just divide it by half. I'm just thinking, what if the length is imagining 1 2 2 2 1. What if it is odd? So the length is 1 2 3 4 5. 5 by 2, it's gonna be 2. Half is gonna be 2, right? So 2 0 0 1 2. So okay, maybe 1 2. Okay, just go till this and reverse this other half and compare it. Okay, so int length is gonna be get length maybe, so I'm gonna pass head. It's gonna turn me this int get length list node head, uh list node current is gonna be head int length, while current is not equal to null, length plus plus current is gonna be current dot next. Okay, let's return this length. We've got the length, and half is gonna be length by 2. So we have to iterate till the half. So while I'll use the pointer list node current, so it's gonna be null initially. So while half minus minus greater than 0, if current is equal to null, current becomes head, or else current is equal to current dot next. So now I'll go to the half one and I'll divide it. So current next is gonna be current dot next. Current dot next is gonna be null. So I'll reverse the current next. Reversed reverse of current next. I'll get the reverse one. So now I'll be taking 2 pointers. List node A, which is pointing to head. List node B, which is pointing to reverse. So now while A is not equal to null and B is not equal to null, if A dot value is not equal to B dot value, return false. A is equal to A dot next, B is equal to B dot next, and return true at the end. I think this has to work. Let's see. Let's try to run this. I think this is the longest, easiest question we have solved. Okay, okay, we forgot to remove this shit. Okay, let's try to run this. Okay, let's use some extra test cases. Come on, come on. Okay, let's submit. Next is do some. Did it work? Okay, it didn't work. Okay, if it is of length 1, where it is going wrong. Okay, if it is of length 1, then return just true. Okay, let's try that edge case. If head is equal to head dot next, maybe head equal to null, and head dot next is equal to null, return true. Let's see if this works now. Come on. Oh, still. Why is it going till there? If head dot next is equal to null. Let's copy this. Interesting. Okay, so of course we'll get again the same thing. Let's see. Cannot read. Okay, because it is null. Array man, if it is null, then we are just returning true, right? Head is equal to null and head dot next, or okay, got it. I think now it works. Silly me. Okay, yeah, let's try to submit this. Succeed or not? Succeed. Oh yeah, it worked. Let's try to increment the pointer. Okay, do some. Okay, this is a standard problem. Hash map. Hash map makes things faster. Hash map, new hash map. Okay, so now iterating. Int I is equal to 0, I is less than nums dot length I plus plus. So target is this, right? So remaining will be target minus nums of I. If map dot contains key of this remaining, return new integer array of map dot get rem along with the current index. Else just put it in the map dot put um nums of I with its index. Now return new int of maybe an empty array. I think this works. Let's try to run this once. I'm sorry if you're getting any background noise, but there is a construction going on aside. So sorry if you're getting that. Okay, cool. It worked. Let's increment the pointer. Okay, so you're claiming. Okay, this is standard DP. So I'll use a standard DP memoization. Again, hash map integer DP new hash map. Right. So okay, so int dfs int n. If n is equal to, if it is 1, then I think its answer is 1, right? If it is 1, return 1. If n is equal to 2, return 2, or else gfs of n minus 1 plus gfs of n minus 2. dp dot put n with this result, return result, or else if dp dot contains key of this n, return dp dot get n. At last return dfs of n. I think this works. Let's try to run this once. Yeah, let's try to submit this. Okay, it worked. So we are done with almost all the questions, I guess. Let's try to run this. Did we add counter properly? The counter says 18. Oh yeah, we have done. So 18, all easy are done. So the time is okay. We took a lot of time, 35 minutes. Okay, let's jump to medium. Let's go to the medium. Let's come back to hard at last. So let me filter with the difficulty, the acceptance. Okay, let's go to the one which has more acceptance. Okay, 79. Partition labels. Okay, why is it taking a lot of time, man? Okay, partition labels. So you're given a string as we want to partition the string into as many parts as possible, and you know that the partition is done by after concatenating all the parts. Okay, resultant string should be as result. Return a list of integer representing the size of these partitions. Okay, each letter appears at most once. Got it. So what I can do is take a hash map and store the last index of that. I think that works. Okay, that I think that works. And see if it is greater than or not. If it is, okay, got it. As many ones as possible, right? So got it. So what I can do is I can take a hash map So it's going to store character along with the integer. So maybe a map, new hash map, new hash map, and starting from the end, int I is equal to s dot length minus 1, I is greater than or equal to I minus minus. If not map dot contains key of s dot caret I, or no, return. I have to add that. So map dot put s dot caret I with its index. Okay, I think this will store the last indices of the each character. So now it's time to keep track. So int max is gonna be 0 and int start is gonna be 0. So I'm gonna use a list to show the answer. So new array list, maybe an array list, and starting from the beginning, s dot length and I plus plus. My throat started to get dry already. So we're gonna take the maximum index first, the last index. So max index is gonna be from the max map dot get s dot caret I. So we are checking if max index is greater than the current max. Max is gonna be max index. If I is equal to max, then it's time to add to the answer. Answer dot add I minus start plus 1. Start is going to be I plus 1. Max is going to be 0. At the end, return. I think this is the right for loop, right? Okay. Return answer. I think this works. Let's try to run this once. Oh yeah, let's try to submit this. Yeah, it worked. Oh, we need to open a new tab. Let's go back till problems. Okay. Loading is taking a lot of time. Like, okay, permutations. Subsets generate k smallest element in st. Let's start with the permutations first. Okay. Come on. Okay. This is standard permutation. So Boolean visit, and I'm gonna take a variable int n. So n is gonna be nums dot length, which is gonna be new Boolean array of size n. So let's do I mean, I use DFS as a name every time. So nums and return answer. So the answer is gonna be a list of integers, and it's gonna be answer. So now answer is equal to new array list, right? So now after add also use a list for the path to new array list. So now at the end, void dfs in nums, this is a list, right? So list integer array list the path. So if path dot size is equal to n, that means we have got a permutation. So I'll use an extra array list for storing this new array list. Path dot add all from the temp dot add all, sorry, temp dot add all from the path, and answer dot add temp and return. Or else what am I doing, man? Okay, so for int I is equal to 0, I is less than n I plus plus. If not visitor of I, then visit that I by saying visitor of I is true, and go there dfs of nums, and I have to add in the path as well, right? So for that, path dot add nums of I. and I'll go to there by using this path again. So again I have to remove path dot remove path dot size -1, which of I gonna be false. Yeah, I think this works. Let's run this. Did we forget to increment the pointer counter? Yeah, I guess. Well, let's do that after doing these three questions as well. Yeah, it worked. Subsets given an integer array nums of unique. Okay, this is also a backtracking kind of thing. So I've seen like this solution like in a book called as Cracking the Coding Interview. So that's a nice book. So yeah. So GFS in nums int start the current index. If start is greater than or equal to nums dot length, I'm gonna turn new, or maybe like I'll create a global. So list integer answer new array list, return this answer. Or else what I'm gonna do is I'm gonna call the next. So integer list of list, I'm gonna get the sets from this call nums of start +1. So now I'm gonna iterate through each set. So list integer set, from the sets I'm gonna create a new list integer temp new array list, and temp dot add all of, first thing I have to add this answer dot add all of the sets. So temp dot add all of set temp dot add a current one, which is nums of start, and answer dot add temp. I've done the explanation of this question in my channel. So yeah, so at the end return answer, on return DFS nums with 0. I think this works. It's been 44 minutes. Oh, why is it wrong, man? Okay, I got it. Answer dot add a new array list. It's an empty set. This is the main thing. We need this. Yeah, let's try to submit this. Yeah, cool. Generate parentheses. Given a pair of parentheses, while write a function to generate all combinations of well-formed parentheses. So this is like balancing parentheses. So maybe again DFS int. I'll use n, and I'll use two variables called as open int close. So this is gonna count the number of open and close. So I also have to store this string, right? I have to form a string as well. String prefix maybe. If prefix dot length is equal to n start 2, what I'm gonna do is answer dot add prefix and return. Or else if open is less than n, GFS n open +1 close prefix plus open. If or else if close is less than or open, GFS n open and close +1 and prefix plus close. I'm gonna create an integer array, a list, I mean integer list, answer new array list. GFS n is n 00 empty string return answer. I think this works. Let's try to run this. Okay, I've run that. Okay, Okay, it's a string, sorry. Run code. 46 minutes. Okay, a lot of time. So let's try to submit this. Let's see if this works. Yeah, it worked. Let's go to the next question. Kth smallest element in the BST. Given the root of a binary search tree, an integer k, return the kth smallest. Okay. Are they sure that there would be a kth smallest always? K is always less than. Okay, okay, so it's guaranteed. So got it. One way is to just do in order traversal and just find that, or else I can do one thing. What DFS tree node root int maybe like PTR is one index, right? One. I'm going to do in order. So root is equal to null return. So now I'm gonna go root dot left. Now I'll be coming to the root. So now what we're doing is if PTR is equal to k, then we got the answer. Answer is equal to root dot value. So what are we doing is if answer is not equal to null, is equal to null, then only I'll be doing this. I'll be going deep. Similarly here, if answer is equal to null, DFS root dot right, I'll be taking a reference type. So null initially. So DFS root and I'll use int k. K is gonna be here. This dot k is gonna be k and return answer. I think this works. Let's see. Is this gonna work? No. Why it didn't work? So the answer which you're getting is 3. 1, 2, 3. Kth smallest. But the expert is 1. Okay. In this case, k is okay 1. So answer is root dot value. Got it. If PTR is equal to k, in this okay, I have to increment PTR as well. PTR plus plus. I think now it works. Oh yeah, let's use some example test case as well. Yeah, let's try to submit this. Let's hope it works. Come on. Yeah, it got succeeded. So how many are we done? Let's try to reload this. Let's make sure our counter is good or not. Of course it's bad, but 23. So we have to increment 19, 20, 21, 22, 23. Cool. Let's go to the next questions. 2, 3. So these are the 4 questions. Let's see what is create image. Rotate image. So you are given an into n 2D matrix representing an image. Rotate the image by 90 degrees. Okay. This is just doing a transpose and swapping. I think you got it. Okay, I got it. So first thing I have to do transpose. For int I is equal to 0, I is less than n, right? Anyhow, so it's a square matrix. Int n is going to be matrix dot length. Sorry for that, my throat is already struggling. I've never spoke this much before. So n I plus plus for int I is int j is equal to I j is less than n j plus plus. Now transpose, so I comma j becomes j comma 1. So in temp is gonna be matrix of I comma j. Now matrix of j comma I becomes, oh shit, this has to be I comma j, sorry. Matrix of j comma I, uh, matrix of j comma I is gonna be temp. This is gonna create a transpose. So now we have to swap. Sorry for this. So for int I is equal to 0, I is less than n by 2. I can do till n by 2, right? If it is odd, 3 by 2, it's 1, 1. Okay, less than or equal to, less than n by 2. That works. I plus plus, I plus plus. Or else I can do one thing. Let's make things easier. I can take left as 0, right as n minus 1. These are going to act as pointers. So I'm going to do this n while for n times. This is going to be the row. So while L is less than R, what I'm going to do is swapping these two. In temp is going to be matrix of I comma L. Matrix of I comma L is going to be matrix of I comma R. Matrix of I comma R is going to be temp. L plus plus R minus minus. I think this works. Let's try to run this once. I'm tired already. Why it didn't work? 741. This is not swapping, and this is not swapping. Why? We have took 2 pointers. Okay, we have to bring back the L and R again, right? L is equal to 0. R is equal to n minus 1. I think now it works. Yeah. Cool, let's try to reload. Run the other test cases as well. Oh, okay, submit. Come on, man. Okay, cool. Rotate my image. Let's increment the pointer. Let's go to the next one. Daily temperature. Given an array of integer temperatures represents the daily temperature return in array such that arrays of I is the number of days that you have to wait for the ith day to get a warmer temperature. If there is no future day for which it is possible. To be honest, I didn't get the question, but let's see the example. 73, 74, 74, 75, 75. Okay, you have to find the distance between the next greater element. Maybe I can use stacks. I would definitely have to do some a drawing part. So what is the input? So we are having the input as 73, 74, 75, 73, 74, 75, 71, 69, 72, 76, 73, 72, 76, 73. So as I said, I'm using a stack, right? So maybe a stack initially I think is there 73. So the next one is 74. The top of the stack is less than the current one, right? So for that the greater element would be 74. I'll remove this and add 74. And now the greater element. Okay, got the approach. So stack, so integer stack, new stack. I'm going to store indices this time. For int value, okay, I is equal to 0, I is less than, and I plus plus. I'm going to use n for that. Int n is going to be temperatures. That's a big name. Temperatures dot length. And now what I'm gonna do is while um st dot size is greater than 0 and st dot peak, it's gonna be index, right? So temperatures of st dot peak is less than uh temperatures of I. Then what I'm gonna do is uh I'll take an answer array first. So int answer new int n, right? So now temperatures, the inside one will be answer of st dot peak is gonna be I minus st dot peak plus 1. Only play, I think it's that's minus, and st dot pop. Yeah, I think this works. And then st dot push the index, return answer. Let's see if this works. I'm a bit doubtful in this, but okay, it worked. Let's see some extra test cases. How many times, man? Like run code. Oh yeah, let's try to submit this. Oh, thank God. Let's increment the counter. Combination sum. Given an array of distinct integers, candidates, and target number. Okay, return all the unique combinations of candidates where the chosen number such sum to target. You may return the combination of any order. Any order. Okay. Return the combinations in any order. That's the requirement, right? So let me see the example. Candidates, combinations. Okay, I've given a target. So the one combination is 2 to 3, and okay, there is also 3 to 2, but we need unique one, so that's why they have written only once. So other combination is just 7. Got it. So maybe what I can do is um I can do one thing. I can find all the combinations and sort them, and uh this is a bit tricky, obviously. Wait, do we have, okay, all elements are distinct. Okay, we don't have to worry. Okay, got it. We don't get any duplicates. So void dfs int candidates. So int, I'll get the target and the current sum and a list for the path and the current index. So what I'm going to do is from this index, for int I is equal to start, I is less than nums dot length, candidates dot length, in this case candidates dot length I plus plus. I'm just seeing some. Okay, let's do one thing. I can use a number as many times as possible, right? So path dot add candidates of I, and this to dfs candidates and target and sum plus candidates of I, the path and I plus 1, or I only. I can use this. I can use any as many times as possible, right? And if you come back, path dot remove candidates of I, or I mean path dot remove path dot size minus I minus 1. And yeah, so if sum is equal to target, then I'll store the path. Did you see that? Like the difficulty increased, like when I've come from easy to medium, how much time I'm taking. Integer temp new array list. So now temp dot add all of path and answer dot add temp return, or else there's a case if sum is greater than target, don't do anything, just return. That's it. I think this is going to give me the list of answers. So list and list, and I'm going to name it as answer new array list. So now I'll just call DFS candidates with target with 0 sum initially, with an empty path initially, with 0 as index initially. Oh yeah, so return the answer. Let's see if this works. Run code. Yeah, oh shit, it worked. Got it. Okay, yeah, it worked. Cool. Let's go to the next question. Increment the counter. Okay, palindromic substrings. Given a string is return the number of palindromic substrings in it. Palindromic substrings. Okay. A string is palindrome. Okay, I know what is a palindrome. Okay, I know what is a substring. Return the number of. Can I say return the number of palindromes in this? What's the length of the string given? 1000 only, right? So can we have an overlapping? Yeah, I can have. Okay, I can just find. Firstly, I find all the palindromic substrings and just count them at the end. So for that, I'm gonna find the palindromes. So I'm gonna use a DP approach for that. New int. So this is gonna be int n s dot length. So n comma n matrix. So now for int I is equal to n minus 1, I is greater than or equal to 0, I minus minus. For int j is equal to I, j is less than n, j plus plus, j plus plus. If I is equal to j, dp of I comma, obviously if it is single character, it's a palindrome. And yeah, so else if j minus I plus 1, j minus I plus 1, yeah, is equal to 2. If it is of size 2, I have to see s dot caret I is equal to s dot caret j. Then dp of I comma j is gonna be 1. Else if j minus I plus 1 is greater than 2 and s dot caret I is equal to s dot caret j, and dp of I plus 1 comma j minus 1 is equal to 1, then dp of I comma j is equal to 1. So this is going to give me all the palindromes, and I'm gonna find again. So is less than n, I plus plus, int j is equal to 0, j is less than n, j plus plus. If dp of I comma j is equal to 1, count plus plus, at the end return count. I'll be creating the count variable, and let's try to run this once. Yeah, let's try to use some extra test cases. Okay, it worked. Let's try to submit this. Yeah, it worked. Let's increment our counter. How many have we done? Let's try to refresh. I want to see whether I'm incrementing the counter exactly right or not. Okay, at 27. Let's go to the next questions. Kth largest element in the array of a frequent elements product of array except itself. Okay, let's try group anagrams. I definitely have to cut like almost 10% of the time at the end because of this loading time. So group anagram. So given an array of strings, group the anagrams. Okay. Okay. Obviously, I'm gonna sort it. So what I'm gonna do is let me do one thing. I'm gonna use a hash map. As I said, hash map makes things faster. So a string with the list of strings map new hash map for each string s from this str's array. What I'm going to do is convert this to a character array as dot to char array and sort this character array and create a new string from this sorted one ch. So now if map dot contains, or let's do one thing. Okay, let's do this only. Contains key of str. If let's say map not contains map dot put the str along with a new list. I think yeah. So now map dot get str. Oh, my fingers are not working. Get str dot add the current is. So now at the end, I can just maybe for map dot entry of type a string and a list of string. I think this works. Yeah. So now m map dot entry set. So answer dot add m dot get value. Okay, I think this works. Return answer. Let me create an answer list. So this is gonna be this answer. So new array list. Okay, I think this works. Let's try to run this. Okay, map dot contains. Okay, spelling mistake. Okay, yeah. Submitting this. Yeah, it worked. Let's go to the next question, incrementing the counter as well. Kth largest element in an array. Given an integer array nums and the integer k, return the kth largest element in the array. Okay, obviously this is a heap. Priority queue integer. For finding the kth largest, I can use a main heap. I'll maintain the heap of size k. New priority queue. So for int value value nums, what I'm gonna do is q dot add, it's min heap, right? Min heap dot add value. If min heap dot size is greater than k, min heap dot poll, and then return min heap dot peak. This has to work. Let's see. Yeah, let's try to submit this. Whenever someone asks you to find the top k or like that, top k frequent, like top k largest or smallest, then heap is a the best thing. So even in here, top k frequent elements, right? So given an integer array, we have to find the top k frequent elements. So what I'm going to do is top k frequent elements. Return. You may return answer in the order. Okay. So again, to find the frequency, a hash map. it's gonna be of type integer, it contains value and its frequency. Map new hash map. So now what should I do? Okay, I have to show the frequencies. For int value of nums, map dot put map dot get, or default get is value, or else the default is 0 plus 1. I have to place value here. Yeah, I think this works. So now I said priority queue. Priority queue, it's of type, I'll use an integer array where it contains only two indices, one for value, one for its frequency. So queue new priority queue. I have to write a comparator, because if you're not using any integer type, then you have to use a comparator. So in this case, comma b, as we have to top k frequent elements, so I have to use a max heap, b of 1 minus a of 1. So now for map entry integer m map dot entry set. Okay, so now q dot add, let's get the values first. So value is gonna be map m dot get e, and frequency is gonna be m dot get value. So now q dot add new int array where value is this value, frequency is this frequency. So now while k minus minus greater than 0, k times, what I'm gonna do is let's create an answer array. Int answer, it's gonna be of size k. So now int let's use this a for loop. For int I is equal to 0, I is less than k, I plus plus. I can just remove this. So answer of I is gonna be q dot poll dot poll of 1, I mean 0, return answer. Let's see if this works. Yeah, let's try to use some extra test cases. Okay, 1 hour 14 minutes, and we're done with 30 questions almost. Just 30 questions for 1 hour, and we have to do 100 questions. Imagine how much time it's gonna take. So incrementing the counter 29, the product of array except self. So I have done this question in my channel, I have explained that. So obviously it's a prefix some kind of question. So int left product, so and int right new int of n. Left of 0 is gonna be nums I mean nums of 0. Left of 1 is gonna be nums of, I mean this has to be n minus 1, sorry. Right of n minus 1 is gonna be nums of n minus 1. For int I is equal to 1, I is less than n, I plus plus. Left of I is gonna be left of I minus 1 star nums of I. Similarly for int j is called n minus 2, j is greater than or equal to 0, j minus minus. Right of j is gonna be right of j plus 1 star nums of j. So now again for int I is equal to 0, I is less than n, I plus plus. So if I is equal to 0, answer of I is gonna be right of I plus 1. Else if answer of, I mean I is equal to n minus 1, answer of I is gonna be left of I minus 1, else answer of I is gonna be left of I minus 1 into left of right of I plus 1. Return answer. Let's create an answer array. So it's of size n. So if n is equal to 1, return return nums itself, I guess, right? Let's try to run this. Let's see if this works. Okay, it worked. Let's try to submit this. Yeah, it worked. Let's try to increment the counter. Let's refresh. Let's see how many done. It says 30. Is that correct? Yeah. Oh, 31. Then I have to increment one extra. Okay, the next question. Level order, unique paths, bedroom partitioning, right side view. Okay, let's start this level order traversal. For 8 minutes and 31 questions solved. A binary tree level order traversal. Given a root of a binary tree, return the level order traversal of its nodes. Okay, got it. I have to find the level order traversal and return it as a list. So initially what I'm gonna do is I'm gonna create two lists. One would be a parent new array list. Another would be a child new array list. So now parent dot add root. So this is going to be of type tree node. You have to be not an integer, it has to be a tree node. So while parent is not equal to parent dot size, the size is not equal or else greater than 0. So now I'll be iterating. First of all, I'll add to the answer array. So answer array is something which is of 2 dimensions. So list of lists. So answer new list. Okay, so add to answer. I'll use a method for that and I'll pass the parent on. Now for each free node from a node from this parent list, if node dot left is not equal to null, children dot add node dot left. Similarly, if node dot right is not equal to null, child dot add node dot right. So now parent becomes child and child becomes new array list. I think you got this right. So at the end, return answer. I'll be passing the answer here as well. Answer. So it's going to be a void add to answer. I'll be passing a tree node type parent and along with the answer. I don't have a patience to again type this shit again. I'll just copy this. So I have to convert this to an integer and just okay, yeah, int. Let me use streams if that possible. Parent dot stream and dot map for each node, convert it to node dot value and dot collect it as collectors dot to sorry to list, uh, and this will give me the list, and at the end answer dot add this thing. If that works, then it would be a wonder. I have never tried that, so let's see. So yeah, I think this works. Let's try to run this once. No, it worked. Let's submit. Okay, it didn't work. Okay, if it is a null, return this thing. I hate edge cases, man. If root is equal to null, return answer. I think now it works. Yeah, it worked. So let's go to the next question. Unique paths. I think I have done this question before in my channel as well. So just finding the all the unique paths. This is basically a DP. So int DP new int of size m comma n. So the boundaries are gonna be of same. Int I is equal to 0, I is less than m, I plus plus. DP of I comma 0 is gonna be 1. For int I is equal to 0, I is less than n, I plus plus. So dp of 0 comma I is gonna be 1. So starting from the 1, I is equal to 1, I is less than n, m, right? I plus plus. For int j is equal to I, j is less than n, j plus plus. Dp of I comma j is gonna be dp of I minus 1 comma j plus dp of I comma j minus 1, and return dp of m minus 1 comma n minus 1. Yeah, let's try to run this. Yeah, let's try to submit this once. Yeah, it worked. Let's go to the next question. Palindrome partitioning. So given a string as partition as such that every substring of the palindrome partition is a palindrome. Okay, every substring of the partition. Return all possible palindrome partitions. What is the length? Okay. Interesting. Partitioning. We have done similar question before, right? Palindrome substrings. I think, is that going to help in here? No, I guess like this is gonna be different. Palindrome. Okay. Of course, this is a backtracking ones, but I'm just saying, do we have to find it every time? I mean, you have to find whether a particular substring is palindrome or not every time or not. I can do one thing. I can make sure I can find out all the substrings are palindrome or not. Like just we have done the DP array, right? I'll do that, and I'll do the recursion like DFS and just see. Uh, got it, got it. So first things, the same thing, the same approach. So the same DP. So int n is equal to s dot length. In DP is gonna be new int m comma n. So now for int I is equal to 0, I is n minus 1 minus 1, I is greater than or equal to 0, I minus minus. For int j is equal to I, j is less than n, j plus plus. Phi is equal to j, dp of I comma j is equal to 1. Else if j minus I plus 1 is equal to have to be minus 1 plus 1 is equal to 2, and s dot caret I is equal to s dot caret j. So now dp of I comma j is gonna be 1. Else if j minus I plus 1 is greater than 2, s dot caret I is equal to s dot caret j, and dp of I plus 1, it has to be 1, and j minus 1 is equal to 1. Then dp of I comma j is gonna be 1. This is gonna create me all the substrings whether it's random or not. So now uh I'm just seeing, wait 1 second. So we have done with this. So now the next step is I can maybe as a recursion, right? So let's do one thing. I can just do normal recursion dfs starting with the current start. I need the path as well, right? So string path, and also I need a string s along with the dp array. So now if start becomes s dot length greater than, then I have to add this path to the answer. So string temp new, maybe I can do the streams path again, streams. So answer dot add path dot stream dot um dot collect collectors dot to list and return. I think this works. Or else starting from for int I start I is less than s dot length I plus plus. So now we're gonna do this, which is I'll be getting the substring from here. So string sub is gonna be empty initially. So sub plus is equal to s dot correct I. If dp of start till this I is equal to 1, then that's a partition. So dfs first thing path dot add this sub, and dfs I plus 1 path s and dp, or else dp I mean path dot remove path dot size minus I. I think this works. So yeah, I think this is it. Let's try to run this. I mean, we're left with some things. Call this method by passing 0 new array list along with s and dp and return answer. I have to create the answer. I'll just copy this from here. Answer new array. Yeah, so return answer. I think this has to work. The reason why I've chosen the recursion is there are no more constraints. I mean, no uh length of size here. It's just 16, right? So backtracking of course works in that case. Yeah, let's try to submit this. Come on, work. Time limit exceed. Oh, it worked, thank god. Okay, cool. The next question, let's try to increment the pointer. I think we forgot to increment pointers, I mean the counters. Why am I using pointer for counter? Okay, I think I forgot to increment counters for some questions. Let's verify that later. So binary tree right side view. Okay, after written the right side view, got it. So okay, so keep track of the depth, and for the previous depth is smaller than current depth, then add that. So in preview initially gonna be -1. So void dfs int depth tree node root. If root is equal to null, return. If preview is less than, first I have to, okay, I can go directly. So if preview is less than the current depth, preview becomes depth, and answer dot add root dot value. So now I'll go to the towards the right first. DFS of depth depth plus 1 and root dot right, and GFS depth plus 1 root dot left. And now integer array, oh this one integer array, sorry. So integer answer new answer array list. So now GFS with depth initially 0, and passing the root, and return answer. I think this works, this must work. Okay, cool. Yeah, let's try to, we forgot a case, right? I guess not. Yeah, let's try to submit this. Okay, come on. Yeah, it got succeeded. Let's increment the counter. Let's try to refresh once. How many are we done? 35, 33. We forgot for 2. Okay, 35. So there are many, man, many. Not just this page, there is another page as well, and along with that, hard questions as well. Shit. Flattened binary tree. Okay, implement. Right. So let's start with the flattened one. Flat binary tree. Okay. Seriously, taking a lot of time, man. Okay, given a root of a binary tree, flatten the tree to a linked list. So I can do one thing. Maybe I can store this in the list and maybe take just append or just give the connection for the left and right. Or else I can do one thing. I can do recursively that. So if root is equal to null initially, return, that's it. Or else flatten root dot right, flatten root dot left. Now I'm gonna do the attachments. The tree node left is gonna be root dot left, tree node right is gonna be root dot right. So now root dot left becomes null, and previous, I'm gonna use a variable called previous root because I'll be storing this previous node here. Pre node previous, got it. So I think this is it. Let's try to run this. Okay, wrong answer. Where it went wrong. Okay, we are taking the left and we are taking the right. Okay, first we have to keep this root dot right. It has to be pre. Yeah, I think now it works. Yeah, let's try to submit this. Cool. Let's increment the counter this time. So minimum path sum. Given an element grid filled with non-negative integers, find the path from top left to bottom right. Minimizes a sum of all the numbers along with its path. You can only move either down or right. So this is like a unique path sum. So just like a unique path. So I'll use a DP array. M is going to be grid dot length. Int n is going to be grid of 0 dot length. So int dp new int m comma n. So for int I is equal to 0, I is less than, let's start with 1, or else let's start with okay, let's start with 1 only. So dp of 0 comma 0 is gonna be grid of 0 comma 0. So now starting with 1 less than m I plus plus, dp of I comma 0 is gonna be dp of I minus 1 comma 0 plus nums of grid of I comma 0. Similarly for the columns, for int I is equal to 1, I is less than n, I plus plus, dp of 0 comma I is gonna be dp of 0 comma I minus 1 plus grid of 0 comma I. So now for int I is equal to 1, I is less than m, I plus plus. For int j is equal to 1, j is less than, j is equal to 1, j is less than n, j plus plus. As we can move from, you can go only towards the right and the bottom, right? So for this case, dp of I comma j is gonna be math dot min of dp of I minus 1 comma j and dp of I comma j minus 1 plus grid of I comma j, and return dp of m minus 1 comma n minus 1. This has to work. Let's see. Yeah, let's try to submit this. Do we have an empty array as well as an input? Oh no. Okay, cool, it worked. Let's increment the counter. So construct a binary tree from its pre-order and in-order traversal. So I know what is a pre-order and I know what is in-order. So given a two integer arrays, okay, and pre-order and okay, got it. So what they're trying to do is they're giving you as in pre-order, in order. So pre-order is something which is at the beginning. So root in order 3 9. Okay, I think in order is enough form, I guess. No, right? Pre-order. Okay. Okay, okay. I have to go till okay the next of R. I think I need to use I think I have to use a whiteboard for sure. Let's use a whiteboard. 1 second. I'll be using a whiteboard. So this is, what is the input? So the input given is 3 9 20 15 7 20 15 7. This is a pre-order. What is the in order? 9 3 15 9 3 15 27. So now pre-order contains the first node, right? I'll be putting 3 initially and going towards the left. Okay, I have to stop at the point where I find the first in 9. So I'll be finding 9. So when I get 9, which is equal to this, I'll be returning back return. Now okay, I have to come here 20, go left, and 15. I think I'm doing right. 15 15 and 7. I think there's some ambiguity in this, but still trying to rectify whether it's correct or not. I don't think there might be some issue with this, like many edge cases as well. First we have to make sure we get till the place where we come to this in order. Okay, so what I can do is maybe uh I can use two pointers. One would be at here pre-start, make name it as pre-start maybe, and one pointer in start, and similarly maybe this would be okay. 0 1 2 3 4 5. 0 plus 4 by 2 2 1 2. 15 is the mid. Okay, I think I got it. So what I can do is I have to make sure I iterate this pre-order till I find the first element, the pointer where the in start is, and that would be the end. And yeah, I got it. So that would be the base case here. So what I can do is, as I said, I'll be creating a method. So maybe a method returns a tree node dfs. I'll be using some pointers: pre-start, int in start, in start, and int in end. I think I don't need pre-end. Yeah, I don't need pre-end. So along with the pre-order as well, and in order as well. So now if first thing, let's take this tree node. Let's create a node, tree node root, new tree node of the pre-order ones, pre-order of pre-start, pre-start, that's it. So now I'll be taking the in index, starting with that int in index is gonna be 0 initially, and for int I is equal to 0, I is less than or equal to in and I plus plus. If in order of I is equal to root dot value. So now it's time to assign index I. So now going towards the left, root dot left is gonna be dfs. Okay, pre-start increases, pre-start plus 1, in start remains the same, in index decreases, and sending the pre-order and in order. Similarly, root dot right is gonna be dfs pre-start minus, not minus, pre-start has to increase, it has to increase in index minus in start plus 1. Yeah, this is the case. And in index plus 1, in and pre-order and in order, return root. And at the end I'm just going to call this method return dfs 0 0 and in order length dot length minus 1 and pre-order and in order. This must work. Let's see. This is like a bit complex question. Okay, interesting where it went wrong. Oh, I forgot the base case. Sorry, base case important. So if in start is greater than in end, or maybe if pre-start is greater than pre-order dot length minus 1, return null. I think this works. Let's try to run this once. Okay, still pre-order. It has to be small. Spelling mistake. Any other? No. It's been 1.45 hours. Cool. It got succeeded. Let's try to submit this. Okay, got accepted. Let's go to the next question. Implement try. So this is standard try implementation. So let's get into this. So tree, I'll use a node data structure class node. It's gonna be maybe like it contains a value, right? A word or a character. It contains two things, right? One is a children int. Let's take a boolean, or let's take a node children new node of size 26. Let's make 27, and boolean is end. These are two things. So I'm gonna create a node root is equal to node. So inserting a word, right? So now node current becomes root for int I is equal to 0, I less than word dot length I plus plus, getting the current character. So current index is gonna be word dot caret I minus a. This is gonna give me the exact index. So now if current dot children of index is equal to null, current dot children of index is gonna be new node. Current is gonna be current dot children of index. At the end, current dot is end is equal to true. And now the search thing, I can just do the same almost, to be honest. So if it is null, return false, or else return current is not equal to null and current dot is end. And this is also almost same, I guess. So it's gonna be here. Okay, so I guess return true. Okay, let's see if this works. Okay, where it went wrong? Node. Okay, I have to add the constructor node. Cannot find symbol node. Okay, sorry. Actually, we have a default constructor anyway. Don't have to add the constructor. So current word. This is, let's make it as word. Okay, let's try to run this. Okay, it got succeeded. Let's try to submit this. Let's see if this works. Oh yeah, it worked. Oh, cool. So let's increment. What are the questions? Let's try to refresh. 39 questions for our counter, but it says how many? Show it, man. Why is it showing 0 by 0? Let's reload again. Okay, 39. Okay, it's correct. So let's go to the next questions. Swap node in pairs, find duplicate, longest common subsequence, unique binary search trees. So these are the questions. Let's take 4 by 4. Okay. Swap nodes in pairs. Given a linked list, swap needs two adjacent nodes and return its head. You must solve the problem without modifying the values. Okay. So this is basically changing the connections. What I can do is I definitely have to use a whiteboard for sure. So what is the input? 1, 2, 3, 4. 1. Let's use this feature. So 1, 2, 3, and 4. What I can do is maybe I can use 2 pointers, like first and second. I can use a dummy pointer like this. So first this gonna pointer call as p. So p dot next is gonna be second, because we have to swap. So ptr dot next is gonna be s, and I'm going to store the s next as well. So s next would be this sn. So now s dot next would be f, and f dot next would be sn. This would be the logic. And what if I'm just thinking, what if this is null? F, okay, second shouldn't be null. So what I can do is after this logic, f becomes sn and s becomes f dot next. I think this works. Let's try to do this. So as I said before, list node dummy, new list node -1. So now yeah, so iterating. So it's gonna be 2 pointers. List node first, it's gonna be head. List node second, it's gonna be head dot next. So while second is not equal to null and second dot next, I think second is not equal to null, right? Yeah, second is not equal to null. What I can do is as I said before, ptr dot next, using a ptr list node dummy. So ptr dot next is gonna be second, and second dot next is gonna be first. First, let's store the second node, second next. Second next gonna be second dot next. So now ptr second. So first dot next is gonna be second next. So now ptr becomes first. Ptr is gonna point to first. Come on, first. And first becomes second next. And second, I mean, this has to be second next. Second becomes first next. If first is not equal to null, so or let's do one thing. If first becomes null itself, then we can just break it out. I think this works. Okay, let's see. I think this is it. Let's return dummy dot next. Okay, let's try to run this. Oh, I'm sorry. Okay. Okay, as expected, something would be there. So if it is of size 1, then head would okay. What I can do is if head is equal to null or head dot next is equal to null, return head. If this works, let's see. Okay, let's submit. Oh yeah, it worked. Okay. Find the duplicate number given containing in +1 where each integer. Okay. There is only one repeated number. Return there is. I don't want to waste any time. I'm gonna go with the hash set. Hash set integer set new hash set. for int val from nums if set dot contains of value, return value, else set dot add val, return -1. Let's try to submit this. Okay, it worked. Okay, cool. Incrementing twice, right? Yeah. So longest common subsequence. So given two strings and we have to find the length of longest common subsequence. Okay, I think I have seen this like before. So this is kind of like a DP problem. What I can do is I can try to do recursion first and then try to back optimize the overlapping situations. So what I can do is let me draw it. I mean, for sure I have to draw for this question. Even I don't get like so what is input? So input is A B C D E A C E A B C D E A C E. So if the first pointer, if these are equal, then going forward. If they are not equal, either I have to remove this one and go this at this place, or I have to remove this one or go this place. So yeah, so these are the cases. I got it. So basically, I'm gonna use a recursive function. String A, string B, int I, int j. If I is greater than or equal to a dot length, or b or j is greater than or equal to b dot length, return 0. Or else I'll be storing the state. So if dp dot contains key of I comma j, so I'll using a pair I comma j, return dp dot get pair of I comma j. Or else if a dot caret I is equal to b dot caret j, has to be a capital case. My energy levels are decreasing. I think you have noticed that. Okay, a dot. Let me. Okay, so now okay. So a dot caret I is equal to b dot caret j. So now return. I mean not return. I'm good. I'll be going forward. So int result is gonna be dfs a comma b comma I plus 1 comma j plus 1. So now dp dot put what I'm gonna put the state of it, pair of I comma j with the result, and return. Or else what I'm doing is I have to find the maximum of this. So the result would be math dot max of dfs of a comma b comma I plus 1 comma j, or dfs of a comma b comma I comma j plus 1, and the last dp dot put pair of I comma j with the result, return the result. Yeah, so I'm gonna create a dp map, right? So hash map integer, not integer, string with its integer dp is equal to new hash map, and return dfs of text1 text2 0 comma 0. I think this works. Let's try to run this once. Okay, oh, I forgot to implement the pair method. It's going to return a string. This is a simple method, like just to concatenate them. Return I plus j. That's why. So pair. Okay, return the result. Sorry. Let's see now. Okay, 0. Why? Where it went wrong, it's 0 but output is 3. Maybe we forgot some edge case. Maybe I is greater than a dot length equal to b dot length returning 0. Are we putting in the map? Okay, we are putting in the map as well. But where it went wrong, man. We're getting the result. Oh shit. So we have to add +1 here as well. Just to increment there. Oh yeah, so let's try to submit this. Okay, cool. Oh, it took a lot of time, but yeah, it got succeed. So the next question, unique binary search trees. Unique, okay, given an integer array and integer n, and you return the number of structurally unique BSTs which has exactly 8 nodes of unique values from 1 to n. I think I've seen this question kind of like before, like this is a DP basically. So this is like I've got no, this is like a catalan number or something. So I think I can do that, but I'm just seeing like how can I approach that. 1 3 2 1 2 3 and 2 1 3. Okay, I got it. Basically I can use the DP again. So what I can do is initially if n is clever anyhow, it's 1. Answer is 1. Or else in DP I'll use a DP array, single dimension, int n, and dp of 0 is gonna be 0, dp of 1 is gonna be 1, where int I is equal to, I is greater than, I mean less than, equal to n, I plus plus, and for int j is equal to 0, j is less than I, j plus plus. dp of I is going to be dp of I plus dp of I minus j minus 1. I think this is it. Into dp of j. I think, yeah, I think this is it. So return dp of n. I think this works. Let's see this once. Come on, come on, come on, come on. Okay, somewhere it went wrong. Index out of bound. Why? We are going. Okay, forgot one thing. I have to make it +1. Got it. So, okay, still wrong answer. Okay, these are size +1 and j plus plus. We're using j and I exactly the right way. Plus dp of I minus j minus 1. Why is it going wrong, man? We're initially designing with 0 and coming back to 1. Int I is equal to, and int j is equal to 0, j is less than I, dp of I. Okay, it is going wrong somewhere. Let me think. dp. I'm just verifying if the formula is right or not. Where do you think it went wrong, man? This dp is really shit, man. That's why I don't like dp. Okay. It has to go wrong somewhere. Oh, got it. So this has to be 1 initially. Yeah. Here itself there is a, if n is equal to 1, I is equal to 1. N is equal to 0, I mean n is equal to 0, okay, n is equal to 0, I is equal to 1. Yeah. So let's see. Got it, submit. Yeah, it worked, thank God. So how many have we done? 42 it says. Okay, 43 it seems. Cool. So let's go to the, there are many, man. See, there is also a next page as well. How much time? It's been 2 hours. Okay, that's okay. Lowest common ancestor of a binary tree, decode strings, colors, number of lines. Let it load, let it load. Come on, come on, come on, come on. Okay, number of islands. So this is standard question. Like GFS. So what GFS in maybe the x and y coordinates, I mean the row and column along with the grid. Let's name it as grid. I'll be making grid of x comma y is gonna be, I'm gonna make it as, we are going to traverse to ones, right? Okay, we are going to make it as 0 then in that case. Oh, it's a character array, so it's going to be character, 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 character. So for 4 directions is less than 4, I plus plus int new cell would be di x of I plus x, int b is gonna be dy of I plus y. So now I have to see if it's valid or not. If valid, u comma v comma grid, go there. U comma v comma grid, boolean valid int I int j int grid, I mean character grid. Return I is greater than or equal 0 and j is greater than or equal 0. I is less than m and j is less than n, and grid of I comma j should be 1. This is the case. So I'll be using these arrays or directions. Comma 0 comma 1 comma, this has to be an array. 0 comma 0 comma 1 comma minus 1 in dy 1 comma minus 1 comma 0 comma 0. Oh, and similarly int m int n, so m is going to be length and n is going to be grid of 0 dot length. Now for int I is equal to 0, I is less than m I plus plus. For int j is equal to 0, j is less than n j plus plus. If grid of I comma j is equal to 1, dfs I comma j comma grid, return the islands. So I'll be using the count. So int count is gonna be 0 initially. I'm gonna count it here. So int count, I mean count plus plus. Let's see, this is it. Let's see if this works. Okay, nice. Where it went wrong, it says 0. Okay, this should be character 1. Let's see now. Okay, still nice. We are converting it to 0, right? Anyhow, but why is it saying 9? Is it I'm very surprised that even this question is not working for me. J plus plus give dot I is equal to 1. If it is a land, then only we are going to do a DFS, right? So I'm going to increment count and doing DFS and converting every cell to 0 and going only if the next cell is 1. Okay, here also got it. So let's try to run again. Yeah, submitting this. Yeah, it worked. Incrementing the counter and sort colors given an array nums. And okay, this is like a Dutch national flag algorithm. So int L is gonna be 0, int M is gonna be 0, int R is gonna be nums dot length minus 1. So while M is less M maybe yeah, M is less than nums dot length. I mean M is less than R. Or let's take nums dot length. So if nums of M is equal to if nums dot length is equal to 0, or maybe let's take if nums dot length is equal to 2. So now nums of M is equal to nums of swapping these two, right? So nums of R, maybe let's swap this in temp. Nums of M is going to be nums of R, nums of R is going to be temp. I'm going to decrement the M. I'm going to decrement R. Else, if nums of M is equal to 0, nums of L, just swap these two in temp. Nums of M nums of L is gonna be temp L plus plus M plus plus. Return uniterated anything. Let's see if this works. Okay, time limit exceed. Interesting. Somewhere the pointer is not increasing as expected. If it is 2, what are we doing? We are just, if it is 0, then we are swapping with and incrementing both, else only decrementing R. Okay, or else, okay, forgot a case. If it is 1, else M plus plus. I think this works. Okay, then this have to be, M should be less than or equal to R. Will this satisfy now? Oh yeah, let's try to submit this. Cool. Let's go to the next question. Decode string. And encoded string, return that decoded string. Encoded rule is a okay, encoded string where the encoded Okay, you imagine that the input is always valid, there is no extra white spaces. Okay, this is basically like a stack thing. Okay, yes, so I can use a stack and got it. I can use something like one stack to store the numbers and one stack to store the words. So yeah, I think that works. So maybe stack integer nums stack and stack string new stack. So now starting from the first, so while I is less than a start length, I'll take the first character as dot char at I if character dot is digit of C. If it is a digit, then I have to extract all the digits, all the side by side digits. It might be like 10, 12, right? In this case, it's a single digit, 2, 3, like that. But there might be multiple, like off range, see, 300 it seems. So okay, I have to find all the characters. So in ki, what I can do is while character dot is digit of s dot caret k or I, I plus plus. The reason why I have used k is to keep track of the first place. So now the number would be string num s dot substring of k to I. I think you got this. So I have to convert it to number. So num dot push nums dot push num, I'll use parse int integer dot parse the num. So else if C is an open one, in this case maybe what I can do, maybe I can just push some words dot push and empty, something like that, and increment the I. Else if C is equal to a closed one, so what I can do is take the top of the num stack and I have to repeat that times. I mean times would be nums dot pop, and I'll get the word as well. String word gonna be words dot pop, and I'll use a result variable. So for times I have to append this. So result plus is equal to word. So now words dot push words dot pop plus res. So I'm going to take the top one and append that to this. Okay, so else what I'm going to do is words dot push words dot pop plus character. Yeah, I think this works. And incrementing I plus plus, and at the end the answer will be the top of the data. Where's the while loop? While is here. Okay, return words dot pop. Let's try to run this once. Where okay, I think I have to add something in the stack, maybe something in this words push some empty. Let's try to run now. Oh, still, where is it going wrong? Okay. Mm-hmm. Okay, substring. Okay, it's an open. We're just pushing words dot pop. Oh, we forgot to increment I here. Okay, I think now it works. Yeah, let's try to submit this. Cool, it got succeeded. So let's go to the next question. Let's increment our counter. Oh yeah, so given a binary tree, find the lowest common ancestor of two given nodes of the tree. So okay, for 5 and 1, the lowest common one is 3. Got it. So there might be, okay, 5 and 4. Okay, for 5 and 4 it's 5 only. So what I can do is I can just do like a post order. I can do a post order traversal kind of thing, and boolean dfs uh tree node root tree node p and q. I want to use this, and if root becomes null, return false. I'm gonna go left, boolean left gfs root dot left p and q. So what I'm gonna do is, if I'm gonna take the right as well, so in right is gonna be dfs root dot right p and q. If left and right, I mean if the left is true and right is true, I return true only if the value is either p or q, right? So if left and right answer is equal to root, else if left or right and root dot value is equal to p dot value, or root dot value is equal to q dot uh, is equal to q dot value root, or else if root dot value is not equal to I think it doesn't satisfy, because if it is equal to anyway it will be here. So now we have to check either this case is equal or not. So if root dot value is equal to p dot value, or root dot value is equal to q dot value, I can just return true because one satisfied, or else return left or alright, any of this satisfies. So yeah, again as I said, I'll be using an answer, right? So integer answer is gonna be null. So if I find null answer, then I don't have to iterate, go towards the right. So if answer is not equal to null, then only is equal to null, then only I'm going to do that. So or else if answer not equal to null, return true here as well, return true. So what I'm just gonna do is call return dfs, oh no, I want to return this root pq return answer. Let's see if this works. Okay, tree node, right? Sorry, tree node, it has to be a tree node. 2 hours, almost 2.5 hours. Submit. Cool, succeeded. Okay, I think we're done with all. Even this is done, right? Okay. How many are we done till now? I'll be incrementing for the current one. It says 47. Yeah, 47 only. So the next questions. This. Let's go ahead. So now little combinations of one more. So this I have done before. I've done a video on this as well. So yeah, I think I can manage this question. But there is like a shittiest thing in this question. I'll tell you what. Uh, so I'll do backtracking, right? What? DFS again. I'm sorry. I'm feeling sleepy. I don't know why. DFS. Okay. So I'll be taking the string digits, and the current index. So if index becomes if index or after the prefix, right? Let's take the prefix. String prefix. So if prefix dot length is equal to digits dot length, so answer dot add prefix return. Or else what I'm going to do is I'm going to take the current digit and digits dot caret index minus 0. So now I'll be getting the characters which are mapped to this 0. So it's going to be like I'll be taking an array. That's the shittiest part in this question. So char letters is going to be get letters for this digit. I'll be iterating through this letters TFS digits index plus 1 prefix plus letter. So now the main part comes, getting the letters. It's gonna be a char array get letters. Let's name it as letters in digit. So now letters. So for 0 it doesn't have anything. For 1 it doesn't have anything. So for 2 we have A, we have B, we have C. So for 3 we have D, E, F. For G, H, I, J, K, L. Similarly, sorry for this slow typing. M and O and O, P, Q, R, S. So T, U, V. To V. So the last part W, X, Y, Z. Done. Finally return letters of digit. Yeah, this is it, I guess. So I'm storing this in answer, right? So answer array of type string. Answer is going to be new array list. So GFS digits with 0 index in the beginning and empty string. So return answer. I think this has to work. Let's see. Yeah, let's submit this. Okay, so an empty string. So if it is an empty string, return answer. This is a nice edge case. So if digits dot length is equal to 0, return answer. Let's see if this satisfies. Oh yeah, cool, we are done. Let's go to the next question. Container with most water. Given an integer array height of length n, there are n vertical lines drawn such that to okay. Point a line that together action from okay. We have to find the maximum number of amount of water container can store. So one is a brute force using two natural for loops. So another I can do like this. So 0 int r gonna be I dot length minus 1. So while L is less than R, what I'm gonna do is I'm gonna find the length. Int length is gonna be R minus L. Int breadth is gonna be math dot min of height of L comma height of R. So int area is going to be length into breadth. So now answer is gonna be math dot max of answer with this area. So if height of L is less than or equal to height of R, L plus plus, else R plus plus. So then return answer. So I'll use a variable for that answer 0. Let's run this. Okay, nice. Array index, where it went wrong. R is n as R length minus 1. Height of okay, R should decrement. Okay, got it. Okay, submit. Yeah, it worked. So sort list. Given a head of linked list, run the list after sorting it in ascending order. And I can't do this insertion sort or some sort with this linked list, so I'll just do the something which is fastest. So what I can do is okay, let me do one thing. Okay, so I'll do one thing. This is the worst approach, but I'll do this. Integer list, new array list. List node current is going to be head, while current is not equal to null. List dot add current dot value, current is equal to current dot next. So now collections dot sort list. So now list node dummy is gonna be a new list node with some value, and list node ptr gonna point dummy. So now for each value int value from list, I'm gonna create a new node, a list node, new node, and new node, and it's gonna be this value, and ptr dot next is gonna be new node, and ptr is gonna be ptr dot next, and then return dummy dot next. I think this works. Yeah, let's try to submit this. Cool. Next one, min stack. Design a stack that suppose push pop top and retrieve the minimum element from the constant time. Okay, I can maybe do this. I can use two arrays. So int st would be one array. Will they be giving us a size? How many calls are they gonna do? 3 power 3 into 10 power 4. Maybe I'll use 3 1 2 3 4. So similarly, when st new new int 3 1 2 3 4, right? So what I'm gonna do is st of, I'm gonna use a top variable. In top is equal to 0 initially. So what I'm gonna do is or maybe, okay, let's use top 0. So st of top is gonna be this value. Min st of top is gonna be math dot min of min st of or let's do one thing. So if top is equal to 0, just do this add because it's the first. So let's do some indentation. What the heck? Okay, so this is gonna be the value itself. Else st of top is anyhow gonna be value, and min st of top is gonna be math dot min of value and min st of top minus 1. At the end, increment top plus plus. So for the pop one, for pop, okay, pop both the values. So just decrement top minus minus. I think that works. For getting the top value, return st of top. I mean top minus 1. Hello. Yeah, who's this? किधर से? Okay. नहीं नहीं नहीं. Oh, this is gonna be top minus 1, and get min, this is gonna be get min, so it's gonna be on the return min st of top minus 1. Let's see if this works. Submit. Yeah, cool. Let's increment. So now how many have we done? 49, 51, man. We have crossed the half century as well. Okay, so longest increasing subsequence search path sum 3. Okay, let's go there. Now we even complete one page. Ugh, man, this is really terrible. Okay, let's go to this question. Okay, given an integer array. Okay, this is a standard question, standard DB question. So what I can do is same the TP, right? So I'll do the DFS int DFS int nums and int start. If start is greater than or equal to num start length, return 0, or else where int I is equal to start plus 1, I is, okay, let's do it from 1. I is less than num start length I plus plus equal to. If start plus I think I can do this, is greater than or equal to num start length, I can break it out. So in that case, we don't have to check this condition. You can break it out. So now I have to see if nums of start plus I is greater than nums of start, then I can go there. DFS nums with I plus start. So I'm gonna add the count int the max one 0. Max is equal to math dot max of max with DFS. This is gonna find the maximum increasing subsequence at this point. So dp dot put start with this max and return max plus 1. It's gonna be max plus 1 here as well. So if not here, sorry, but why did I do it here? So it's gonna be here. Oh man, I have copied something from previous question. So int max 0. So if dp dot contains key of start, return dp dot get start. Okay, this satisfied. So now I think I'm missing something. dp dot get start and okay, I have to why did I write this inside, man? So control V, and yeah, I think this is it. This is the function. So let's create the map. Integer dp new hash map. So dfs nums with the 0 return. I can do one thing. I can use int answer. It's gonna be 0 initially. Answer is going to be math dot max of answer with max plus 1. At the end I can just return answer. This has to work. Let's see. Okay, nums. Okay, let's run again. Okay, wrong answer. Nice. So plus 1, start plus 1, we're breaking, or else if start plus 1 is greater than start, okay, then we are going to the I plus start. Okay, then we are trying to take answer and dip put answer and max plus 1. Why is it going wrong? Let's try to print this. dp okay, why only just okay from 0 it's 10. Okay, it's 2. From 9 it should at least put 0, right? Okay, it is not increasing, so it won't go there at all. Okay, I got it. So I have to do this. For int I is equal 0, I is less than nums dot length I plus plus. I can do this. I think now it has to work. Still didn't work. Okay. Okay, I have to pass a tie here. So now I think it works. Yeah, let's remove this, comment it out. Let's submit this. Let's see if it works. Yeah, cool. So write an efficient algorithm that searches a value target in the matrix. Okay, insert teachers a row sorted. Okay, top left right, top two. Okay, this is I can do like this. So I can start from the I is equal to 0 into j is equal to, let's do this, dot length int n is equal to matrix, so n minus 1. So while I is less than m and j is greater than or equal to 0, what I'm going to do is, if a matrix of I comma j is equal to target, return true. Else if target is greater than matrix of I comma j, go downwards, I plus plus, else j minus minus, return false. I think this works. Let's see. I think this works for sure. Let's see. Yeah, let's try to submit this. Yeah, cool. Maximum subarray. The unit integer, find the contiguous subarray containing at least one number which has largest sum and its sum. But this is like cadence. I don't know how to pronounce that, but this is that algorithm. So int max is gonna be integer dot min value. This has to be capital. For int value from nums, max sum plus is equal to be val. Sum is gonna be 0 initially. So now max, oh sorry, not here. Max is gonna be math dot max of max with sum. If sum is less than 0, sum is equal to 0. Return max. This has to work. Let's see. Yeah, let's try to submit this. Cool, it got succeeded. Let's go to the next question. Path sum 3. Given a root of monetary and integer target sum, return the number of paths where the sum of the values along the path equals target sum. So this is just like the 2 sum one. Okay, I can use a hash map. Okay, cool. So as I said, I'll be using a hash map. So it's of type integer map new hash map. So now initially I have to put something in the map because the target is equal to the root, then we have to put 0 in the map, right? So that's why map.put 0 comma 1. So I'll use a function called dfs. I'm gonna pass root target sum along with the current sum. At the end, return some value. Maybe we have to find the number of paths, right? So maybe the count. So for showing the count, I'll use a global variable. So now the main part starts, implementing the dfs function. So void dfs tree or root int target sum int the current sum. If root is equal to null, we have to return. Now or else sum plus is gonna be root dot value. I'll find the remainder. Int rem is gonna be target sum minus the rem, the current sum. Oh, okay, I think might be exceed. Some might exceed, right? Sum minus target sum. So now if map dot contains key of the remaining value, then count plus is equal to map dot get rem. So now map dot put sum with map dot get or default the sum 0 initially and 1, right? So now I'll go towards the left target sum with sum, and towards right root dot right target sum with sum, and removing from the map dot put sum map dot get or default the sum map dot map dot get. Okay, it's yeah, I can do this. So I can maybe do 0 and -1. So now I think this is it. Oh yeah, I think this is it. Let's try to run this. Oh really? Let's see this. Cool. Let's try to submit this. I didn't expect it would pass. Oh yeah. See, as I didn't expect, it went in that way only. So answer is 2, but the expected is 0. Output is 2. Where did it go? What is the target is 0. So the expected is also have to be 0. Where did we go wrong? So we are going left and we are going right, and coming back we are decrementing. Of course this is right. Coming to here, this is also right. Let's first of all copy this. So now let's see. We are having some large value. Tree visualizer. Okay, fail to pass your input. Let's remove this and see now. Okay, where it went wrong. We have put a map with some 0 and 1. So now coming to this call root, we are making one, so some remaining becomes sum minus target sum. If map dot contains key of remainder, we are getting that count plus map dot get reminder, or else, and map dot put with the sum, we are going to put map dot get or default the sum plus 1, or else we are going towards the left, target sum and root dot right target sum, and this is also same thing. What do you think the mistake is, like where it went wrong? Okay, I think this is good, but where it went wrong? What if we change this to target sum minus sum? Okay, still not right. Let's put as it is. So now I feel like everything looks fine. Map dot put. There is no target sum 0. So if map dot contains key of reminder, I think this works, but what happened? I don't know. Okay. I don't know, man. What happened? I feel this works fine for sure. Definitely for sure. I don't know why it's not working. Should we go to the next question maybe for some time? Mm, let's go to the next question. Oh man, this is the first time. The first question which is very messed up. So let's go to the next question. We're done with this. So let's do refresh. Let's see how many we are done. 54. So 2, 3, 4. Got it. So now copy list with random pointer, set matrix 0, longest consecutive sequence, on like 5 nanograms in string. It's been like 3 hours. Continuous 3 hours. Okay, let's keep this here only. Or let's can remove this one, see this later. Copy list with random pointers. So I've seen this question before. So there are two ways. One is without using a hash map, and one is without using a hash map. I'll use a hash map for completing it faster. Hash map node and node map new hash map. So now I'll be starting from the first. Current is equal to head. While current is not equal to null, I have to store the new nodes, right? So current map dot put current with new node with the same value, current dot value. Current is equal to current dot next. So again current is equal to head, while current is not equal to null, current dot random, I guess, right? So here it is current dot next. Let's do this. Current dot map dot get current dot next is equal to map dot get current dot next. I think this works. Similarly for random one as well. Map dot get current dot random is equal to map dot get current dot random. Current is equal to current dot next. Okay, so at the end returning map dot get head. So yeah, I think this works. Okay, let's use some extra test cases. Let's submit this. Yeah, cool. So the next question, set matrix zeros. Given an m into n integer matrix, if the element is 0, set it to entire row to zeros, or else set it to, okay, you set entire rows and columns to zeros. There are like two ways. Like you can use an extra matrix, and I can do the if I find any element 0, I'll do the entire row and column as 0, set the entire row and column as 0. Maybe I can do that, but there will be some easier and faster one. There is an easier and faster one, which is I can use this the same matrix only. So what I can do is I can store, if anything is 0, I can store in the top one first column, so that makes things faster. So m is equal to matrix dot length int n is equal to matrix of 0 dot length. So what I'm going to do is, for int I is equal to 0, I is less than m I plus plus. For int j is equal to 0, j is less than n j plus plus, if matrix of I comma j is equal to 0, if I'm just saying, okay, matrix of I comma 0, we make it as 0, matrix of 0 comma j is gonna be 0. And yeah, and there is a case if I is equal to 0, maybe like first row is true. If j is equal to 0, maybe like first column is true. So at the end, this is the loop, right? So what I'm going to do is, starting from the bottom, I is equal to m minus 1, I is greater than or equal to 0, I minus minus, for int j is equal to n minus 1, j is greater than or equal to 0, j minus minus. If matrix of I comma j is not equal to 0, and matrix of I comma 0 is equal to 0, or matrix of 0 comma j is equal to 0, and this is also a case, I is not equal to 0, or the first row contains a 0. I think, am I right? Oh yeah. So, and similarly j is not equal to 0, and first column contains 0, then matrix of I comma j is equal to 0. I think this works. I forgot to initialize boolean fr is equal to false, boolean fc is equal to false. Let's see if this works. Okay, nice. So okay, this has to be j, sorry. Okay, it didn't work. Is it actually okay, this is same, this is not same, this is not same. So might be wrong in these conditions. I might have messed up. Okay, and okay, if has to be the first column contains 0, or the first row contains 0, and I is not equal to 0 and first row contains, and j is not equal to 0 and first column contains. So this has to be or. Yeah, okay, so now I think it works. Yeah, so let's try to submit this. Yeah, cool, it got succeeded. So now the next question, oh, I have to increment the counter as well, we are forgetting that. So longest consecutive sequence. So given an uncertain array of integers, return the length of the longest element sequence, consecutive element sequence. So in this case it's 1 2 3 4. I can maybe use a hash set, like a hash set or hash map, something. So what I can do is let's do this. 100 plus 1 is not there in this, 4 plus 1 is not there in this, 200 plus 1 is not there in this, 1 plus 1 2 is there. So in this case its maximum is 2. So 3 plus 1 4, 2 plus 1 3 is there. Maybe I can do in that way. um got it. First thing what I can do is just like that. So I can maybe use a hash set as I said before. It's gonna store some integers. Set new hash set for int value from nums. Set dot add value. And now what I'm gonna do is I'm gonna take a variable called as max to keep track of the maximum length. Right. So for int I is equal to 0, I is less than nums dot length I plus plus. So initially count would be, for a single digit count would be 1. Right. So now int num, the current nums of I. So now the thing starts. While set dot contains of the decrement value minus of num count plus plus and set dot remove num. And now again num of I, num is equal to nums of I. Again, while I'm just seeing the decrement and increment values, I mean going backwards and going forwards. So file set dot contains of plus plus num count, this has to be like this, count plus plus set dot remove num. Now max is gonna be math dot max of max and the count, return max. I think this works. Return. So yeah, let's try to run this. Yeah, let's try to submit this. Cool, it worked. Let's try to increment our pointer. Incremented. Let's go to the next question. Find all anagrams in a string. Given two strings s and p and return an array of start indices. Okay, you may got it. Anagram is okay. I know what is an anagram. Formed by rearranging the letters of different words or phrase. Okay. You may return the start index of the wherever. Okay, I have to find wherever this p anagram is in this s. This is basically like a sliding window. Like normal approach would be sorting all the subarrays and comparing with that p string, but this is like a sliding window. Which should I select? Of course the first one gonna take more time, so I have no other option. I have to take the other one only. So let's do that. Let's do the sliding window one. So I'm thinking how to start. I'll be taking a map for keeping the frequencies of that. We have to make sure the frequencies of this p string should be equal to the substring frequency. So in that case, if that for satisfies, then that's exact anagram, right? So maybe I can do that. So I can use, okay, I have to return an array or a list of numbers. Let me initialize that list, maybe integer which contains answer new array list. So now if at all there is a case where, let's see the lengths. Okay, so yeah, both might be equal as well, must be greater. So if p dot length is greater than s dot length, there is no way return answer, turn zeros, I mean empty one. So or else what I'm gonna do is let me create a map. I think this question gonna take a lot of time for sure. So character and its frequency, let me be like p map, new hash map. So now, how much time it has been? 3 hours 12 minutes. Yeah, not bad. Okay, hash map. So now, I'm going to iterate to the p, this p string. So for int I is equal 0, I is less than p dot length I plus plus. So map p map dot put the current character, which is p dot caret I, and p map dot get or default p dot caret I 0 plus 1. So for int I is equal to 0, I is less than, I'm trying to iterate through the s1 s array. So s string, so s dot length, and I'll be decrementing this from p. So because we don't need the exceeding one, right? P dot length plus 1 I plus plus. So if p map doesn't contain the s dot caret I, just continue, or else if I have to see from the current one or the next. I think this question is a mess. Let's see this question later. This question is going to be a mess. If I try this now, it's going to take forever. Let's try to complete some other questions. This is the second question which messed up. So yeah. How many have we done? 57. Okay, cool. So the next question, find the minimum rotated sorted array house robber partition equals subset. Okay, we're almost finishing the first page partially. Okay, I have never sat this much on a Leetcode continuously. Okay, cool. Okay, I'll remove this. Find the minimum in the rotated sorted array. So okay, this is a binary search. I have done this before, but let's see. So finding the peak, or I know the approach. I mean, I can do the binary search and I have to find the peak one and just return the next one. But so for fast completion of fast, I'll just do the linear search. Please understand, okay? So linear search int min is equal to integer dot max for int val from nums min is equal to math dot max, min of min with value, return min. Cool, I think this works. Generally it is expecting us to do binary search, but just to complete it faster, I'm just doing it linear search. Yeah, see, it got succeeded. Fine. Okay, house robber. If you're a professional robber planning to rob houses along the street, each house has a certain amount of money as stand. Okay, automatically contact the police if position were given and teacher representing the amount of money each house, return the maximum amount of money you can. Okay, got it. This is a dp. So int dp new int of n, and so now int n is equal nums dot length. So dp of 0 is gonna be nums of 0, dp of 1 is gonna be math dot max of nums of 0 comma nums of 1, starting from 2. I is equal to I is less than n, I plus plus. Dp of I is gonna be math dot max of uh, dp of I minus 1 or nums of I plus dp of I minus 2, and then return dp of n minus 1. I think this works. Let's try to run this. Or maybe what if the length is 1? So I can verify that here. In this case, if n is equal to 1, return nums of 0. Yeah, I think this works. Let's try to run this. Whew. Yeah, let's try to submit this. Yeah, it worked. So let's go to the next question. Partition equals subset. Uh, let's complete this. I think I have done this before. Let's search 2D matrix 2 before. What is an efficient algorithm that searches for a value? Right now. Okay, the same approach, exactly the same code, nothing much difference. So what we have done before, int m matrix dot length, int n matrix of 0 dot length, int I is gonna be 0, int j is gonna be n minus 1, while I is less than m and j is greater than or equal to 0. What I'm gonna do is, if target is equal to matrix dot I comma of I comma j, return true. Else if target is greater than matrix of I comma j, increment I plus plus, else j minus minus, return false. I think this works. Let's try to run this. Okay, some mistake. Where expected why? Okay, spelling mistake. Let's try to run. Yeah, it got. So let's try to submit this. Cool, it got. So the next question, given a non-empty array, so contain only positive integers, find if the array can be partitioned into two subsets such that some of the elements in both subsets are equal. Okay, so this is basically a DP as well. So what I can do is, first thing is, if at all I can divide a subset array into two subsets of equal sums, then that actually means a subset have to be a half of the total, right? Total sum. So for that, what I can do is, initially I can find the total sum. So maybe total is going to be 0 initially. So for int value from nums, total plus is equal to value. So now if the total is sum is not equal or not even, I mean, then definitely we cannot divide into two subsets for sure. So total 2 is not equal to 0, return false, or else I'm going to create int half. Half is going to be total by 2, right? So now what I'm going to do is, I'm going to create a method for that. So boolean dfs int nums int target int index. So now it's a base case. So if I'll be doing like a backtracking, so if index is greater than or equal to nums dot length, return target has to be 0. That has to be a case. In this case, target is equal to 0, or else I'll be using a dp array to store the state. So if, I mean, a hash map, or let's use an array maybe. In dp is going to be of size n into n, or in this case it's nums of total, nums of length plus comma total. So dp is going to be new int of nums dot length comma total. I'm going to use a visited array as well. New boolean visited. It's going to be single dimensional. Nums dot length. Right. So now what I'm going to do is I'm going to fill this initially with my negative values. So for int dp arrays dot fill t with negative values, and then return gfs of nums target, and target is nothing but the half, so half and index is 0. So now the main implementation comes into picture. So if it's hard to explain this question this approach, so that's why I'm trying to complete it faster. So if dp of index of target is equal to is not equal to -1, so return dp of index comma target is equal to 1, return true, or else maybe I should have used a boolean dp, but that's okay. So boolean, I'm gonna not take. This is a case where I don't take, not take. So dfs nums target and index plus 1. So there is a case where it's take. I'm gonna put initially false. So if target is greater than or equal to nums of index, so now it's gonna be take will become dfs of nums target and nums of index and index plus 1. Now boolean answer is gonna be take or not take. If any of it is true, then that's the answer. So dp of index comma target is gonna be answer or else 0. Return answer. I think this is it. Are we missing any initializations? Okay, we are missing a boolean. Yeah, I think this works. Yeah, I think this works. Okay, boolean. Again. It has to be target only, right? dp of index comma target is not equal to -1. Why is it going wrong? Oh shit, my neck is I think you heard that sound, my cracking sound. So yeah, dp of index comma target. So why is it going out index out of bound? I think this is good, right? What are we sending? Like you're sending the half, right? So d -1, we are sending nums half and 0. If index is greater than nums dot length, okay, then if dp of is not equal to -1, then index out of bond of then 0. Index is equal to 11. Where it went wrong, man? Man, this is the third question which is messing up again. I think dp of index is equal to target. I mean dp of index comma target. There might be a case where we have done some edge case. I mean some Small mistake. Take and not take. Okay. Take is equal to. I think this works for sure, but why is this not working? Let's get to the question again back. Let's not discuss this now. Let's come back to the question. Yeah, this is the third question which messed up. Let's go to the next question. This is the question which messed up, right? Okay. So cool. So this given array of intervals where intervals of I is equal to start of I, nodes are overlapping intervals, and return an array of non-overlapping intervals. So this is just sorting the intervals and just see the previous one is overlapping the current one. So this is one approach. I think that works, but maybe I'm just seeing if there is any I'm just like thinking if there is another alternative for this. Maybe I can use a priority queue if that's possible. I don't need access. I can do the normal approach only. So what I can do is I can take a list of int and list new array list, and I'm going to store these intervals in this. For each interval so interval of intervals list dot add new, or just add interval. Man, I'm tired already. Collections dot sort list, and I'm adding a comparator a comma 0 minus b comma 0. Yeah, so getting the length of this list dot size. So now node head, I'm going to create a node to store these values. So maybe what I'm going to do is I can do one thing. I'm just converting it to linked list, or maybe let's do one thing. I'm just thinking. I'm tired, man. 1 second, let me think if there is any alternative. Like normal approach is just seeing the previous one and current one and just adding to the answer, but I'm just seeing if there is any other alternative. Maybe I can do one thing. Instead of collecting to us like a list, I can do one thing. Maybe, so this is a two-dimensional array, right? So maybe sort intervals. So I'll use a comparator lambda expression for that. So we're gonna sort based on the start index, right? So so what am I doing? Okay, so it's gonna be a of 0 minus b of 0. um so now we have to traverse, right? So this will sort us. So now I'll create a, answer array, answer array list. So now initially answer dot add intervals of 0. I'll add the first interval, and starting from the second index I is equal to, I mean the first index less than intervals dot length and I plus plus. I'll be seeing it now, like if at all this current one overlaps with that. If s not s intervals of I comma 0. Let's do one thing. In current x or current s intervals of I comma 0, this is a start, and current end is gonna be intervals of I comma 1. So now let's take the previous start and previous end. So in previous s is gonna be answer dot, let's not make it complex, let's do this. So if current s is less than or equal to the last one which is there in the answer, so answer dot get answer dot size minus 1 of, okay, let's do one thing, this is getting critical. So int preview is gonna be answer dot get answer dot size minus 1. Int current is gonna be intervals of I. So now if current of 0 is less than or equal to previous of 1, then the overlapping happens, right? So the case is, if it happens, so now we'll do something, or else we have to just add it to the answer. So it's gonna be answer dot add current. So now the end of the previous one should be previous of 1 is gonna be math dot max of current of 1 comma previous of 1. I think this has to work. Let's try to print once, maybe print ln answer. I think this is not gonna work, so we have to do a loop. In maybe like arr answer. So let's print the arr arrays dot to string arr. Let's return some value, return for now, return new int 0 comma 0. Let's try to run this once. Let's see whether we are getting the right output or not. Like, I'm just printing. Yeah, I think this is working. So yeah, let's create an array. So it is expecting a two-dimensional array, right? So new int, so it's gonna be answer dot size comma 2. So now what I'm doing is for int I equals 0, I is less than answer dot size I plus plus. So result of I is gonna be answer dot get I. So I'll be returning result at the end. I think this works. Oh yeah, let's use some extra test cases as well. Oh yeah, let's try to submit this. Yeah, it worked. Cool. I think we might have to increment the counter as well. Let's see how many we are done. Refresh. It says 57 in our case. How many have we done? Oh, 60. So maybe we have to increment 58, 59, 60. Cool. So the next question, the target sum. Okay, you're given an integer array nums and an integer target. So you want to build an expression out of num by adding one of the symbols. Okay, before each element. Okay, this is like a coin change and kind of thing. Do we have only ones in the nums array? No, right? No, I guess. Okay, we have to make sure, we have to find all the combinations which make up to this 5 target. This is like a coin change kind of thing. Wait, I also can use dp in here as well. Well, let's try. So I'll use maybe a method called as dfs int. So it's gonna take initially the nums array, int target as well, int sum. If sum is let's do one thing. If sum becomes target, how many constraints do we have? How many values? I think it's 20. I think we don't know dp as well. We can just do one thing. So I can do one thing where we have to either add or subtract, right, for a value. So for that, what I can do is I'm just thinking about the duplications, whether it's gonna work or not. I'm sure, but it might work. Like I'm just saying, okay, this is -1 and starts with -1. This is +1. And do we have any duplicates by any chance? I mean, for example, this is gonna be 2,1. You can add 2. Okay, then I can maintain an index there. I can maintain something which looks like an index, and I have to only start from that index. Maybe it looks like so, int index. So now what I'm doing is, if this index is equal to nums dot length, so in this case I have to see if sum became target. If sum becomes target, return 1, or else return 0, or else I'll do the recursive approach, which is either decrementing or incrementing. I mean, either addition or subtraction. So let's name dfs nums, target will be the same, and sum will here in this case is increment with nums of index, and the index will become index +1. And the other way is dfs nums target sum minus nums of index, and the last one is index +1. This will return something, so that something will be stored in this result, and we will be returning that result. I think this works. Maybe this works. Let's try to, okay, we have to call this method as well. So return dfs target, I mean nums target sum becomes 0, and this also becomes 0 initially. Let's try to run this once. Like this is like a Fibonacci series kind of thing, but you can use dp as well. Let's see if it works without dp. Okay, let's try to submit this. I think this has to work because there are less constraints. Yeah, it worked, but it took a lot of time, right? Let's do one thing. Let's try to add some dp here. Hash map. Let's choose a hash map. Integer. So it's gonna be maybe not an integer. So if the sum is same and index is like a state, so maybe I'll use a string and thus the value, the result at that time. So dp new hash map. So what I'll be doing is I'll use like this sum and index as a pair. So after getting the result, I'll store this dp dot put if the state is like this. Like for example, let's take let's initially add it here only. So it's gonna be string state is gonna be sum plus index. So if dp dot contains this state before, then return dp dot get this state, or else let's do this recursive approach, and I don't have to use a pair. What I thought was initially create a method which will concatenate these two and return that string, but anyway, we can just do it here only. So or else just do this state and show the result and return the result. This will also work. This would be a bit more optimized and time saving, I would say. Let's try to submit this. Let's see. It was 954 before. Let's see now. See how much difference. 284 milliseconds. 984, 954 and 284. Lot of difference. Yeah, cool. Then let's go to the next question. Let's increment the counter as well. It's gonna be 61. Yeah. What, and with merge intervals as well. Linker list cycle. Given a head of linker list, return the node where cycle begins. If there is cycle, no cycle, return. Okay, this is, we have done finding a cycle before, like a 2-pointer, rabbit and a tortoise and hare method. Oh, what happened? We think we have decremented something. Why did the size decrease? What is the, okay, I think it's same. So yeah, so first thing is we have to see if there is a cycle or not. If there is a cycle, then we have to go to finding where the cycle begins. So one approach would be using a hash set only. So if I find any like storing them, like for example, let's make it faster. So hash set, is going to be of type list node set new hash set. So for let's name list node current is gonna be add initially. So while current is not equal to null, if set dot contains this current, then return current, or else set dot add current and current will become current dot next. If there is any cycle, it will return in this loop only, or else at the end return null. I think this works for sure. There is an optimized approach as well, but let's do it faster. So submit this. Yeah, it worked. Let's go to the next question. Go schedule increment the counter as well. 62. There are total of num courses you have to take level from. Okay, you are given prerequisites. You must take course BI. Turn to if finished. Okay, this is cons, or like I have done this question before as well. So this is basically what they're trying to say is we have to find whether these courses can be completed or not. So I'll be starting with the nodes which are 0 and degree. So first things first, I'll create n. We have n, let's name it as n for short. Num courses. My laptop is always started to hang, so I have to create an adjacency list. So it's gonna be list of list. It's gonna be adj new array list. So now let's try to create the adjacency list. So a comma b means you must take the course b1 first if you want to take course A1. So b to a, the edge will be from b to a. So int prerequisite, let's name it as p only for now, but this has to be the same, prerequisites. So now adj dot get p of 1 dot add p of 0. This has to be 0, and before that we have to add n list inside this. So for n times and I plus plus adj dot add new array list. So now we have done creating. Also have to create an integrity array. So int integrity new int of size n. So integrity of p of 0. Come on, p of 0 plus plus. So now we have to start with the nodes which has integrity 0, right? So for int I is equal to 0, I is less than n, I plus plus, if integrity of I is equal to 0, q dot add I. So I might have to create a q integer. Q is new linked list. So we are done with adding to the queue. So while q dot size is greater than 0, I'll be using a counter count. This will tell how many nodes you have visited. So I'll take one from the queue out. So what I'll be doing is int current is gonna be q dot poll. So I have to take all the adjacent nodes. So for int v adj dot get current, if minus minus integrity of v is equal to 0, then q dot add that v. I think this has to work, and I also have to increment the counter and then return count should be n. If we have visited all the nodes, then it actually means we have completed all the courses. Let's try to run this once. Come on. Okay, let's use some extra test case as well. Okay. Yeah, let's try to submit this. Cool, it worked. So to the next question and increment the counter as well. So yeah, 63. Word break. So given a string s, dictionary of strings, return true if s can be segmented to space separated sequence of one or more. Okay, so they're trying to say we have to return true if we can divide this s using the words which are there in this word dictionary. So first thing is I have to do recursion because there might be many combinations, right? So might have to do recursion, and I think I have done this before, like okay, I can use dp as well here. There might be an overlapping situation where we come to the same index again and again. So let's do one thing. So it's going to be a boolean method dfs. I'll be using an index in start, or maybe like let's take it as index, or let's do it start and string s, and I have to use this word dict. So I have to see whether a particular word is there in this word dictionary or not. So for searching, let's convert this list to a hash set. So hash set, it makes things easier. String, so let's name it as dictionary. So let's not use this word. Let's use dictionary. We call it as dictionary. New hash set. So for string str, from this word dictionary, add a dictionary dot add str. So now I'll return dfs with the starting index 0 and s and this dictionary. So it's going to be a hash set. So of string dictionary. So now the thing starts. So if the start becomes we have come to the end of the string, then it's definitely true, obviously return true. Or else now from I is equal to int I is equal to start, or maybe let's do one thing. Yeah, let's do it start I is less than nums dot Or let's do one thing. Instead of this, let's try once is less than length I plus plus. I'll use a sub string. So this will become sub is gonna be s dot substring of from start to I plus one, I guess. Start to start plus I. Yeah, start plus I. So if dictionary or contains this sub, then this is one combination. So now what I'll be doing is I'll have an answer. Boolean answer is initially gonna be false. So answer is gonna be answer or DFS. So it's gonna be start plus I and S and dictionary. So the answer will be return answer. So I can use DP here. So hash map based on the integer index and the boolean as value, DP new hash map. So if dp dot contains key of start, return dp dot get start, or else do this entire thing and store dp dot put start with the answer. And yeah, I think this works. Let's try to run this once. Let's see. I'm doubting about this substring case, but is it nums? Not nums. It's gonna be s. So let's run this again. Okay, I know I forgot this case. So if okay, if at all if index crosses, if start plus I is greater than s dot length, this is the case, break. Let's see if this works. Okay, let's use some extra test cases. Yeah, let's try to submit this once. Let's see. Come on, come on. Oh, okay, interesting. With these failing. For A and A, it's becoming false. But we need true. Why is it? Let's try to first copy these ones. Okay, let's run this. Okay, for a single, okay, we are just adding. Okay, it's not going to this case. To this case. Interesting. Okay, okay. We have to go to the end, right? So I think we have to make this go to the end of the list, end of the string. But we are just breaking out the loop here itself, and we are just, that's why this is always being answered as false. So maybe instead of taking the subs like this, I mean taking like this, instead of taking the substring, let's do one thing. Sub plus is equal to start caret I, or maybe let's make this as start and decrement till s dot length, and let's name it as I. And now if this contains, this will obviously go to the next ones. So yes, let's see now. Okay, interesting. Stack Overflow. Why? If okay, this has to be okay. I only. Okay, this should be I plus 1, sorry. I plus 1. And oh yeah, let's try to use some extra test cases. Using a substring method like messes up. This is the best way. I mean, just appending the current character to the previous one. Yeah, it worked. Let's increment the counter. Let's go to the next question. How many have we done? Let's try to refresh. Okay, 64, 64. Okay, cool. I think we are done with this page, but yeah, there are some questions left over. Let's go to them at the end. Okay, so the next page. Yeah. Subarray sums equals k. Can't change. So yeah, let's start. Point change. Yeah, I have done this before, like just like a previous question, like not like previous question, but the one with target sum. So also like a previous question as well. This is a DP problem. So it's gonna look like this. So in DFS, I'm gonna use the coins and int amount, and yeah, these are equal. These are enough. If amount is equal to 0, return 0. If amount becomes less than 0, that actually means the coin which you have used is exceeding, so return integer dot maybe a min value or something. Okay, max value, because we are trying to get some mins, right? Max value. If dp dot contains key of amount, return dp dot get amount. Or else I'm gonna use the coins where int I is equal to 0, I is less than coins dot length I plus plus. So what I'm gonna do is I'm gonna get the max ones, the min ones. So min is gonna be initially integer dot max value. So min is gonna be math dot min of min and DFS call of coins and amount minus coins of I. So now if min is integer dot max value, so it's gonna be why the semicolon, okay, dp dot put with this amount, it's always not possible, so it's gonna be just min. Else dp dot put amount plus min plus 1, min plus 1. So then return min is integer dot max, then return just min, or else I mean this has to be lowercase min plus 1 or else min plus 1. So then return DFS coins and amount. I think this works. Oh, I have to we forgot to initialize dp hash map. So it's gonna be an integer and an integer. So dp new hash map. Oh yeah, I think this works. Let's try to run this once. Okay, so okay, semicolon missing. Semicolon, okay. Yeah, it worked. So let's try to use some extra test case as well. Okay, we have to return, okay, negative. We forgot a case here. So if it is integer dot max value, here return negative, or else okay, let's do one thing. Let's store the result DFS coin amount. So if result is integer dot max, else return, okay, I think this works. Yeah, let's try to submit this once. Yeah, it worked, but it took a lot of time, but that's okay. Let's go to the next question, and simultaneously let's increase the counter 65. Find the first and last position of element in sorted array. Given an array of integer nums sorted in non-decreasing order, find the first. Okay, basically they're trying to make us do binary search, but I'm not gonna do it, obviously. So if the target is not found, okay. So what I'm gonna do is I can do binary search, like get the value, and from there I can I can get the value index, and from that index I can go towards the left and right till the value is the target. That would be the approach. Okay, let's do binary search only. So int l is gonna be 0, int r is gonna be nums dot length minus 1, while l is less than or equal to r. So get the mid is gonna be l plus r by 2 if nums of mid is gonna be target. Let's name it as index is gonna be mid and break. So initially index is gonna be minus 1. So if you don't find the element, then if index is equal to minus 1, return new int of -1 -1, or else forgot to do here. So else if target is greater than nums of mid, then go towards right. So l becomes index mid plus 1, else r becomes mid minus 1. So now if we get the value, index will not be minus 1, right? So what we'll be doing is int s is going to be index, int end is going to be index. So while let's do one thing. While s minus nums s minus 1 is greater than or equal to 0, and nums of s minus 1 is equal to nums of s, then s minus minus. Similarly, while e plus 1 is less than nums dot length, and nums of e is equal to nums of e plus 1. If this satisfies e plus plus, at the end return new int of s comma e. I think this works, but let's see. Yeah, let's use some extra test case as well. If it is a linear search, we would have done much faster, but it's okay. Yeah, let's try to submit this. Yeah, cool, it worked. Let's increment the counter, and let's do the next question. Maximal square. So given an m into n binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. Okay, it's a square. I think this is like a DP approach, like I have done this before, I guess. So this is like a grid matrix grid DP kind of thing. So int m is gonna be matrix dot length, and is gonna be matrix of 0 dot length. So I'll use a DP array, gonna be of size m comma n. So initially max is gonna be 0. So for int I is equal to 1, I is less than equal to m, we're gonna name it, I think I might require plus 1. So it's gonna be 1. I might need an extra row and column, so it's gonna be mi plus plus. Similarly for int 1 j is less than or equal to n j plus plus. So what I'll be doing is I'll be checking if matrix of I minus 1 comma j minus 1 is equal to, okay, this is a character array, so it's gonna be character 1. If this satisfies, dp of I comma j is gonna be math dot min of dp of I minus 1 comma j. I mean, I'm basically trying to find the minimum of 3, the top one, left one, and the diagonal one. I minus 1, let's take it as I minus 1 comma j minus 1, and math dot min of I minus 1 comma j. What am I typing? Min of dp of I minus 1 comma j, dp of I comma j minus 1, and at the end I think we're left with one brace, so this is and plus 1. So now max becomes math dot max and dp of I comma j. So this actually works, but let's try to see. So return. So we are storing only one side, so it's asking to find its area, right? So area of square is gonna be max of max. Let's try to run this once. Yeah, let's try to use some extra test case as well. Oh yeah, it worked. Cool. So let's go to the next question. Let's increment the counter. Okay, so subarray sum. Okay, this is like a sliding window, I guess. Sliding given an area of integers and okay, so it's just sliding window probably. So return the total number of subarrays to sum. Okay, here's sliding window. So basically there are two approaches for this. One would be basically like two nested for loops. The other would be like a sliding window, but let's make it faster. I really hate sliding window, man. Like I have to I might have to do after handling many edge cases. I have to move one pointer forward, we have to decrement another pointer, increment other pointer. That's really a mess. So being a noob coder, we don't want to do sliding window, so let's do brute force. So we know how to do brute force is gonna be 0 for int I is equal to 0, I is less than nums dot length I plus plus for int j from I, j is less than nums dot length j plus plus. We might need the sum, and sum is going to be 0. So sum plus is equal to nums of j. So if sum is equal to k, count plus plus. This is it. See how much faster it is. But not in time, not in runtime. So let's try to run this. Time limit exceed. Oh man, even brute force got time limit exceed. Okay, this is j. This has to be j. Okay, let's try to run this once. Yeah, submitting. I think this time limit exceed again. Yeah. Obviously, we forgot to see the constraints, but it's 10 power 4 only, right? But why did it fail? I was expecting it to run. Is it it's basically trying to force us to do the sliding window? Man, I'm not ready for sliding window now. Okay, we have no other option. We might have to do sliding window only. So let's think. So this is 1 comma 1 comma 1. So subarray sum equals k. So this is 1, this is 2. So we have to decrement the counter. So 1, 2, this one subarray which is equal to 2, and go forward again, these 3, and from there it's gonna be okay. So we have to decrement the left counter as well. I can use like a to sum kind of thing, like a prefix sum like that. So what I can do is like a to sum. I can use a hash map maybe. So I can use a hash map, and it's gonna be of type integer, map new hash map. You don't have to do sliding window actually. So initially there is a case where it has only one index and it has the exact value of k. So then we have to store for that we have to store map dot put 0 and 1. So now I might have to use int sum is equal to 0. So we're gonna do the for loop, and sum becomes nums of I. So I'll see if map dot contains key of, this has to be capital, so contains key of sum minus k, then it's gonna be count plus is equal to map dot get sum minus k, the count, and then map dot put nums or the sum, and the that thing which you have to put the increment that. So map dot get or default sum, if it is there it will get that, or else it will put 0 and add +1 for that, and then return count. This has to work. Let's try to run this once. Run code. Okay, nice. Oh, okay, we already have a return statement, so let's try to return this, I mean run this, sorry. Yeah, let's try to submit this. Yeah, cool. I didn't expect that, but let's increment the counter. Let's go to the next question. How many have we done? Let's try to refresh once. It's a 68 and 68. Yeah, so the next questions, Larry cache, word search. Let's see this question. So move from the head of the list. Okay, given the head of the linker list, remove the nth node from the end of the list and return its head. Okay, this is a bit easy to handle. So I can use a 2-pointer approach. So I'll move one pointer n times, and after that I'll move both the pointers at same interval, and by the end first pointer will be at the nth node from the end. Yeah, so that's gonna be approach. So first it's gonna be head and list node, second is gonna be head. So we have to move this second n times. It is already on one node, so n minus 1 times. In temp is gonna be n minus 1, while temp is not temp is minus greater than 0. Second is gonna be, by the way, what if it has less number of nodes? Let's delete later. So second dot next. So now while second dot next is not equal to null, second is equal to second dot next, first is equal to first dot next, and then return. Okay, I have to remove that. So for that I might have to use another pointer called as some, maybe like preview. Initially let's make it as null. So preview becomes first every time, so I have to remove it, right? So first dot next is gonna be, I mean preview dot next is gonna be first dot next, first dot next is gonna be null, return head. I think this works, but I had an edge case, but let's see. I think this condition fails, second condition. Let's see. See, I as expected, because it has only one node and we have to remove only that one node. In that case, the first and second will always be the same. Pre will be null, so we are trying to remove pre dot next, right? So in that case, what I can do is, if first is equal to head, return null. I think this satisfies. Let's see. Yeah, it worked. Let's submit this. Okay, nice. 1,2, remove the second one. It's returning the second. Okay, interesting. Okay, first, got it. if first, in this case the first is head, so we are returning null, so we have something. Okay, in this case what I can do is first dot next. I think this satisfies. Let's see this works. Okay, let's use example test cases. Yeah, let's try to submit these ones. Okay, yeah, it worked. Cool. Let's try to increment the counter. Okay. The next question, add two numbers. It's still loading. Why is it? This is the only question which is still loading. Why? Let's refresh again. Yeah, I have done this question before. This is my first question which I have put in my channel. So adding two numbers. So basically they'll be reversed. Okay. So what I'll be doing is list node dummy. I'll use a dummy list, new list node. So it's gonna have some unknown value and a pointer which is gonna attach to this dummy. So now while L1 is not equal to null or L2 is not equal to null, we're gonna take the values. N1 is gonna be, if L1 is equal to null, then it's 0, or else L1 dot value. Similarly, int N2, if L2 is equal to null, it's gonna be 0, or else L2 dot value. So now let's get the sum. Oh, by the way, we have to also use a carry. So for that, int carry initially is gonna be 0. So int sum is gonna be n1 plus n2 plus carry. So we might have to get the last digit. Int last digit is gonna be some percentile 10. So let's create a node. So list node, new node is gonna be new list node of value last digit. So ptr dot next is gonna be new node, and ptr is gonna be ptr dot next. Carry is gonna be sum by 10. So now moving the L1 and L2 forward. So if L1 is not equal to null, L1 is equal to L1 dot next. Similarly, if L2 is not equal to null, L2 is going to be L2 dot next. I think this is the loop, and then there might be a case where carry is greater than 0. So if carry is greater than 0, create a new node. List node, new node is going to be new list node of value carry, and ptr is going to be ptr dot next. Oh no, ptr dot next is going to be new node, and at the end return dummy dot next. Let's see, let's try to run this once. Yeah, let's submit this. Oh, yeah, cool, it worked. Let's increment the counter 70. Cool. Okay, word search. Given m into n grid of characters, word string word, return to if word exists in the grid. Okay, this is like a DFS. So basically, how many words, how many, okay, these are of size m into n of size 6 at max. I think brute force also works. Okay, what I can do is let's do one thing. So if not if, so let's start from here. I loop the board I is equal 0, I is less than m I plus plus, for int j is equal 0, j is less than n j plus plus. If board of I comma j is equal to word dot caret caret 0, then this is the starting case. So now dfs return dfs, or else uh, if dfs I comma j comma bird comma bird return true. At the end, return false. Let's see how we're gonna implement this dfs method. Boolean boolean dfs. I'm gonna add int x, int y, string word, and the board char board. Yeah. So now, what are we trying to do? I have to see the adjacent ones. Let's forget about the base case, but let's see. For int I is equal to 0, I is less than for I plus plus 4 directions, the new u is gonna be dx of I plus x, and v is gonna be dy of I plus y. If if this let's do okay. Instead of for example, let's see this case. We are having the word as a b c c e d, so this is a. I'll send this a here, and we have to search for the next one, which is b. We'll come here. I'm seeing when to return true. We'll get d. Will come here. Okay, the base case would be if word or not word. I think it's gonna be index. Let's maintain an index. Int index. If index is equal to word dot length minus 1, then return true, obviously. So what I can do is 4 directions. So valid u comma v, and word of u comma v is equal to word dot caret word dot caret index plus 1. You have to see if it is not visited as well, so that we'll see in the valid method. If it is valid and if it is equal, so then, and dfs of u comma v comma word comma board comma index plus 1 return true, or else return false. And most importantly, let's initialize some things. Dx is gonna be 0 comma 0 comma minus 1 comma 1. Int dy is gonna be 1 comma minus 1 comma 0 comma 0, and along with that a visited array boolean vis is gonna be new. Let's do it here. Int n m comma n, right? M is gonna be board dot length. Int n is gonna be board of 0 dot length. So now this is gonna be new boolean. It's gonna be a 2D array, so m comma n, and here as well, so it's gonna be 2D array. So if it is we have to, this is gonna be new boolean m comma n. So visitor of u x comma y is gonna be true. I think we can have to do like a backtracking, I guess. Visitor of x comma y is gonna be false. So In this case we don't need to do this, but let's see. So let's implement the valid method. Boolean valid int I int j. We are even passing. We have to see. Let's do this initially. So return I is greater than or equal to 0 and j is greater than or equal to 0, and I should be less than m and j should be less than n. If they are inside the boundaries and that value is equal to the next one, and also not visited, and not visited of I comma j, this should satisfy. Yeah, I think this has to work, but let's see. Nice. So return true, line number 18. Okay, let's run this again. Okay, cannot be applied given types. Okay, we forgot to add the index 0. Okay, let's see it now. Okay, still cannot find symbol m. Okay, let's add m comma n here. Int n and run code. Yeah, let's use some extra test case as well. Yeah, let's try to submit this. Hope I don't get any time limit exit. That's the one I pray. Ah, cool. Okay, go to the next question. Let's try to increment the counter to 71. LRU cache. Okay, this is also a famous algorithm. So design architecture LRU cache. So I've got this question. So I've done this as well before. So what I'm doing is I think you know LRU cache. So again, what happened? Why is this decreasing automatically? So what I'm doing is I'll use a double linked list for maintaining the cache. So I'll create a node class node. This contains a value and contains the preview and next node into value. So this dot value is gonna be value. So this is a constructor. So node head, node tail. So initially head is gonna be new node of some value. Tail is gonna be new node of some value, and head dot next is gonna be tail, and tail dot preview is gonna be head. So now I'll have to put, right? So putting is done from the end. Putting is done from the right side and removing from the left side. So okay, let's use two methods for that. Public void add in key int value maybe, and public void remove. He's gonna remove this node. So first thing, let's implement this put method. Put will update the value if a key exists, otherwise add the key value paired to the cache. So if key exists, I might have to see that. So for that, hash map is required. Integer it stores of type node. So map new hash map. So also I'll do the size as well. So this size is gonna be capacity. So let's implement get first. Return the value of the key if exists. So if key dot map dot contains, sorry, map dot contains key of this key. So now I'll get the node map dot get key, return node dot value. Also we have to remove this and add the end. Remove node and add node. So this is gonna be a list node. So removing, adding, and returning that, or else return -1. So now let's implement the put one, put method. So put, we are just adding at the end, right? So first thing, we have to update the value of the key is exist. So first thing, if map dot contains key of this key, do something, or else I have to create a new node. New node is gonna be new node of key and value is required, I guess. So let's take int key as well. Int key. Yeah, this dot key is gonna be key. So initially head will become 1 -1. So now, so if it is not there, so it's gonna be key value. So we have to add at the end, add new node. Okay, this works. No, I guess. So if size is equal to capacity already, then I have to remove one. Remove head dot next, or else or else just add it, add the new node. I guess this works. If map dot contains, what I'll be doing is node current is gonna be map dot get key, and now I have to change the value. Current dot value is gonna be value, and I have to remove this current and add current and return. I guess this works. Now let's try to implement this add method. So we're adding at the end, right? So list preview is gonna be tail dot preview. So now preview dot next is gonna be node dot next is gonna be tail dot tail dot preview is gonna be node dot preview is gonna be preview. This works. Removing this node. So list node preview is gonna be node dot preview. List node next list node next is gonna be node dot next. So preview dot next is gonna be next, and next dot preview is gonna be preview. Node dot next is gonna be null, and node dot preview is gonna be null. Yeah, I think this is it, I guess, but there might be a case where I miss something, but let's see. Let's try to run this once. Yeah, obviously line number 22 can be converted. Node can be converted to list node. Okay, this has to be a node, sorry. Why did I use list node again? Okay, I think this is it. How many? Okay, I think now it works. Let's see. At least no compilation there are. Okay, when we add some node, let's try to increment something. Size cannot find symbol. Capacity. Okay, I can do one thing. If size is equal to map dot size, okay, nice, didn't work, but That's okay, we didn't get any compilation errors for now. We're getting -1 and 1 initially. The size is gonna be initially the capacity is 2, right? So we are appending it, getting well to use the put method. So if map contains, we're doing something, or else we are doing something else. So if map contains, we're getting the current value from getting the key, we're changing the value to this value, removing the value and adding the value and returning. Else creating a node, and okay, we have to see if size is already a size, we have to remove the head dot next. Okay, we also have to remove from the map as well. Map dot, okay, got it. Head dot next. So it's gonna be head next. Map dot remove a head next dot value. I mean dot key. So at the end, add this new node and to the map as well. Map dot put this key along with the new node. We forgot this to do that, so that's why that's the case. Let's run this now. Yeah, let's try to submit this. Hope it works. Yeah, cool, it worked. Let's increment the vector to 72. Let's refresh once. Okay, 72. Okay, let's take the next 4 questions. Rotate array. Cool. How many have left? Okay, we're almost done with medium questions. Let's complete this today. So rotate array. So given an array, rotate array to the right case steps where, okay, this is like I mean there might be a case where k is large, right? So k is large and nums also becomes large. We might do a repetitive step. So first things first, k is gonna be k percentile nums dot length. This is the main case, and the other step would be, now the actual rotation starts. But there is a trick here. I mean, I can return the entire reverse the entire this thing and reverse till k minus 1, 0 to k minus 1 and k minus 1. Okay, so I can do one thing. So I think this is a familiar question. So reverse the nums from 0 to nums dot length minus 1 and reverse nums 0 to k minus 1, reverse nums from k to nums dot length minus 1. So basically void reverse int nums int l int r. So what I'm doing is while then r int temp is gonna be nums dot length, I mean nums of I, nums of l, nums of l is gonna be nums of r, nums of r is gonna be temp, and l plus plus r minus minus. I think this works. Let's try to run this once. Okay, you have to be an array. Okay, let's try to run this. Yeah, it worked. Let's try to submit this once. Cool, it worked. Let's go to the next question and increment the counter 73 jump game. So you're given an integer array nums are initially positioned at the index first index. Each index element is an array. Maximum jump length at that position. So return true if we can reach the last index or false. Okay. this is like this is like a recursive approach, but as they're saying each element represents the maximum ones, right? So I can maybe do like a for loop or like a linear approach. So we need a max, right? So we have to turn true or false. So initially let's do return true. So what I'm doing is int max is gonna be 0, and for int I is equal 0, I is less than nums dot length I plus plus. I'm gonna iterate through this array. So first things first, if max is less than I, what I'm doing is return false, or else max will become math dot max of max I plus nums of I. So basically I'm just adding the current value to the I, so that actually means we have gone to that max index, right? If at all we might reach at a place where max is less than I, that actually means we cannot come to this I, so I'll return false. So I think this works. Let's try to run this. Yeah, let's try to submit this. Cool, it worked. Let's go to the next question. Let's increment the counter 74. Search in rotated sorted rotated. Let's sorted array. So there is an integer array sorted. Okay, I think I've done this also with three string values. Okay, so the array will be rotated and also sorted. The sorted array will be rotated. We have to find a value in that. So that's the case. And log n time complexity is required. So obviously it's a binary search. So first thing what I'll be doing is I'll try to find the place where it is rotated. So if I get this index, I can see if the value is less than greater than in this or in this. If it is in this, I'll do binary search in this or else in this. So what I'll be doing is I'll find the pivot index. So int find pivot. So it's gonna be nums of array. It's gonna be L. I think I don't need L initially here only. So I'll just pass nums. Int L is gonna be 0. Asking nums dot length -1. So while L is less than or equal to R, what I'll be doing is mid is gonna be L plus R by 2. If mid is equal to, or maybe if nums of mid is greater than nums of mid plus 1. So this case only happens at this place, or else it doesn't happen because it is sorted, right? So if it is sorted, the next element will be greater than the current one. But if this satisfies, it's always the pivot. If this satisfies, or mid is the last one, nums dot length -1, then return mid. Else if nums of mid is greater than equal to nums of mid, not equal to nums of 0, then we have to go towards the left. So the left, yeah, right, I guess. One second. If this mid is greater than this value, it will be this side only, obviously. Nums of mid, yeah, I have to go towards the right only, sorry. So L becomes mid +1, else R becomes mid -1. So this will return me a pivot index. If I don't find it, I'll return -1. So I'll get the pivot at the top. So it's gonna be int pivot find pivot. So I'll just pass the nums. If pivot is equal to negative, then basically do the binary search in the entire array. Binary search from nums 0 to nums dot length -1. Else if target is greater than or equal to nums of 0, then what I'll be doing is return binary search of nums from 0 to pivot. And also I might have to pass the target, so here as well, or else at the end return binary search of nums pivot plus 1, so pivot plus 1 to nums dot length minus 1 and the target. So let's implement this binary search method. So it's a boolean, it's a value, so we have to return the index int binary search int nums int l is gonna be int l int r int target. So while l is less than or equal to r, what I'm gonna do is same approach, mid l plus r by 2. If nums of mid is target, return this mid, else if target is greater than mid, I mean nums of mid, basically return, I mean l becomes mid plus 1, else r becomes mid minus 1. It has to be a mid, not m. I'm tired again, so now I'll return at the end, return negative value if not found. I think this works. Let's try to run this once. Okay, it didn't work. So it's expecting 4. Let's see whether the pivot is correct or not initially. So system.out.println pivot. Okay, the pivot should be 0 1 2 3. Okay, it's correct. So we have to see which is not 0, else if target is greater than, target is okay, it's doing basically from 4 to n minus 1. Basically this is going wrong, I guess. If nums of mid is equal to target, else if target is okay, this should be greater than, sorry, target is greater than nums of mid, go towards the right. So now I think it works. Yeah, let's comment it out, the print statement. Let's see with some extra test case, run this. Okay, nice. Where it went wrong, index out of bound. The condition is if nums of mid, okay, I think this should be second, because if it is the last index plus 1 will not be there, right? So that's why. No, I think now it works. Yeah, let's try to submit this. Cool. Let's go to the next question and implement the counter. I think we're done with this as 75. Let's refresh once. 4 hours 50 minutes, almost 5 hours. Oh my god. So 75, yeah, it satisfies. Sorry. No, so I just sneezed. So yeah, so let's go to the next 4 questions. Jump game to next foundation. Okay, so let's go to the next question. Just still loading. Okay, given an array of non-negative integers nums, you are initially positioned at the first index. Okay, each element represents the maximum jump length at that point position. Your goal is to reach out to last index to the minimum number of jumps you can assume. So this is okay. Basically, this is GP. I can do this as a DP approach, just like almost like a coin change or something, just using a hash map and like that. So I can do this. So as I said, hash map integer with integer with its the minimum jumps from that index. DP new hash map. So now I'll use a method int DFS. It's gonna be the index and it's gonna be nums. If we have reached the last index, if index is equal to nums dot length minus 1, then return 0. If we have already visited this index, dp dot contains key of index, return this dp dot get index, or else I have to find the minimum one. So it mean variable integer dot max value for int I is equal to 1, I is less than nums of index, because you can do at max of this value jumps, right? So I plus plus I think should be equal. So equal, and now incrementing for I times. So if index plus I is less than nums dot length, then obviously jump there. So min is gonna be math dot min of min and dfs of index plus I with nums. And at the end, if min is equal to integer dot max value, then dp dot put the index with min, else dp dot put index with min plus 1 min, sorry. At the end, return dp dot get index, and yeah, so return dfs 0 comma nums. How many constraints? 10.4. I'm afraid of time limit exceed right now. Let's see if this works. Yeah, let's try to submit this. I hope for the best. Oh yeah, oh my god, like almost 2000 milliseconds. There might be an optimal approach, but I think this is our approach which I know as of now. But yeah, it worked. That's enough for me today. So yeah, let's go to the next. Increment the counter. Next permutation. So permutation of an array integer rearrange. Okay, for example. Okay, they'll be giving us an array. We have to find the next permutation, the next greater permutation. Got it. So this is basically like a math question. I know this. I mean, there is a logic, there is an intention in this question. Like if you try to find all the permutations of the given array, and it would form like a wave, like a valley, so that if you clearly see, it increases sometimes and decreases sometimes. So that's the main intuition in this question. So n is gonna be nums dot length. So initially let's take I is n minus 2, sorry. So now while I is greater than or equal to 0, what I'm doing is see if nums of I is less than or equal to less than nums of I plus 1, and break. If this satisfies, let's break, or else I minus minus. So in index 1 is gonna be I. So now if I is greater than or equal to 0, let's do one thing. What I'll be doing is I'll get the index 2, which is going to be n minus 1. From there I'll see while index 2 is greater than 0, what I'll be doing is I have to find something which is greater than index 1. So if nums of index 2 is greater than nums of index 1, break, else index 2 minus minus. and at the end swap them, like swap index 1 index 2 from nums. If it is not greater than or equal to j, I mean 0, I becomes index 1 plus 1, j in j becomes n minus 1. So now while I is less than j, swap I comma j nums, I increases, j decreases. Let's implement the swap once. Void swap int I int j int nums. So swapping, so it's gonna be int temp nums of I is gonna be nums of j is gonna be temp, and yeah, this is it. So yeah, I think this works. Let's try to run this once. Yeah, let's try to submit this. Cool, it worked. Let's go to the next question. Let's increment the counter as well. 77. Maximum product subarray. So given an integer array nums, find the contiguous non-empty subarray with an array less has the largest product return. Okay, product. Okay, subarray. Okay, I have to return a subarray which contains a maximum product. What are the constraints? 2 into 10 power 4. Don't you think brute force works? Let's see if brute force works. And is gonna be nums dot length. So initially the max product is gonna max, let's name it a max, is gonna be integer dot main value. So for int I is equal to 0, I is less than num n I plus plus, so int current is gonna be 1. For int j is equal to I, j is less than n j plus plus, current star is equal to nums of j. Max is going to be math dot max of max and current. At the end, return max. I guess this has to work. Let's see. Okay, cool. Let's use some extra test cases. Okay, let's submit this once. Oh, it worked. Oh my god. Why didn't it didn't work before? I mean, for some other question as well. But okay, that's okay. Let's increment the counter. 78. Let's go to the next question. Longest subarray without repeating characters. So given a string is find the length of longest subarray without repeating characters. Okay, this is, I got it. This is basically like a sliding window. I hate sliding window, but one way is brute force. Then I'm not gonna risk for this question because there might be many comparisons, so brute force might not work. Let's do the sliding window only. So to see the repetition, I'm gonna use the hash map, I mean hash set. So initially n is dot length, int I is gonna be 0, int j is gonna be 0. So hash set, a hash set, so it's character set new hash set. So what I'm doing is we need a maximum length, right? So int max initially is gonna be 0. So while j is less than n, I'll take the character which is there at j. Is gonna be s dot caret j. So I'll see if set contains this already or not. If set contains, that actually means it is repeating. If set contains c, then I have to move the first pointer till we don't have this in the set. So while I is less than n and set dot size is greater than 0, char d is gonna be s dot caret I. So set dot remove d I plus plus, and if d is equal to c, break. If it is current character, this break. And at the end, set dot add c, and also keep track of the max. Math dot max of max, it's gonna be j minus I plus 1, the length, and increment the j pointer. At the end, return max. I guess this works. Return max. I guess this works. Let's try to run this once. Yeah, let's use some extra test cases. Yeah, let's submit this. Cool, it worked. Increment the counter. 79 questions. Let's refresh. How many have we done? 79, 79. Okay, it satisfies. Okay, we are left with 3 more medium questions. Let's go. Validate. Okay, validate binary search tree. So I know this question. I have done this question video as well. So it's basically asking you to validate if it is a binary search tree or not. If it is, then return true, or else return false. So that's the requirement. So I'm gonna use the technique of using a in order traversal. It should be in ascending order. So that's the main strategy here. I'll use a previous ones. So if root is equal to null, return true, or else if no, I'll go to the left. If not, DFS of root dot left, return false, or else if prev is not equal to null and prev is greater than or equal to root dot value, return false, or else prev becomes root dot value and go towards right. If not, DFS of root dot right, return false, or else return true. This is pretty much, this is an easy question. So let's try to run this. Okay, why did I use DFS? You know, right, I always use DFS for method names. So let's name it as isValidBSD. So here as well. Yeah, let's see. Yeah, submit. Cool, it worked. Let's go complete. Oh, this is today's question. Okay, let's go to the next question. Validate binary search tree. Okay, this we are done. So threesome. Given an integer array. Okay, this is basically asking us to find the 3 integers where it sum up to given target, or in this case target is 0. So this is basically almost like a 2-sum, but a small variation which is a 3-sum. So I can use 2-sum in this. Yeah, I can use 2-sum in the as a part of this. So what I'm doing is, okay, we cannot contain duplicates as well. So for that, okay, I can sort it initially. Sort nums. So now I'll assign target. So just for good understanding for me, I'll use target as 0. Anyhow it's 0, but I'll use a variable for that. So we need an answer, right? So answer is of type list of list, integer. So now answer new array list. So starting from the first index, I is less than nums dot length I plus plus. So what I'm doing is, I have to make sure I don't visit again same content duplicate ones, right? So If the previous one is same, then I don't have to do this again. So if I is not equal to 0 and nums of I minus 1 is equal to nums of I, just continue the loop. Don't want to do this, don't want to continue this. So, or else I'll get the remaining thing required. The remaining is going to be target minus nums of I. So now for finding the remaining target, I'll be iterating to the remaining array. So it's going to be the starting of that will going to be L is going to be I plus 1, R int R is going to be nums dot length minus 1. So this is like a two-sum approach. So R L is less than R. So what we'll be doing is first see the duplicates here as well. So if L is not equal to I plus 1 and nums of L minus 1 is equal to nums of L, then just L plus plus and continue. Similarly, if R is not equal to nums dot length minus 1 and nums of R plus 1 is equal to nums of R minus minus and continue. Or else now do the validations. So if remaining target is equal to nums of L plus nums of R, then now it's time to add to the answer dot add as a list, right? So arrays dot as list nums of I, nums of L, nums of R. Now L plus plus R minus minus. Else if remaining is greater than nums of L plus nums of R, then we might have to increment the one which has less value. So L plus plus, else R minus minus. I think this pretty much works. So then return answer. I guess this works. Let's try to run this once. Many edge cases we have. Yeah, it worked. Cool. Run code. Okay. Yeah, let's try to submit this. Oh, cool. It worked. 80 questions, 20 more left. Come on. It's been like almost 5 hours, man. Like 5 hours. 5 hours, 9 minutes and 12 seconds. So yeah, longest palindromic substring. Okay, I think this is a standard DP solution. So what I'll be doing is basically let's do one thing. So starting, I'll use int n s dot length. So DP array as well. New int n comma n. Oh, this is gonna be n. So now starting from bottom, I is equal to m minus 1, I is greater than or equal to 0, I minus minus int I int j. J is equal to I, j is less than n, j plus plus. If I is equal to j, obviously it's gonna be a palindrome. So dp of I comma j is gonna be 1 and keep track of the maximum substring, longest palindrome substring. So for that, answer is gonna be initially length, right? So if answer dot length is less than j minus I plus 1, then obviously answer is gonna be s dot substring of I comma j plus 1. I think this is it, right? Yeah, this is it. Or else if j minus I plus 1 is equal to 2 and s dot caret I is equal to s dot caret j, then dp of I comma j is obviously 1, and if answer dot length is less than j minus I plus 1, answer is going to be s dot substring of I comma j plus 1. Else if j minus I plus 1 is greater than minus I plus 1 is greater than 2, and s dot caret I is equal to s dot caret j, and the middle string should be palindrome. So for the DAP of I plus 1 comma j minus 1 is equal to 1, then the same approach, this thing, so it's going to be the same, and at the end return answer. I think this works. Let's try to run this once. Okay, so went wrong. Oh, it has to be n, sorry, it has to be n. Okay, yeah, let's use some extra test cases. Okay, let's try to submit this. Okay, it went wrong somewhere. Expected CCC. Okay, it's of length 3, but we are just sending returning of length 2. Okay, where it went wrong? We are using the same good pointers I n minus 1. Okay, from I to okay n. If I is equal to 1, it's of length 3, right? So j minus, okay, this should be I, sorry. Yeah, I think now it works. Let's try to paste this test case. Yeah, let's submit this. The last medium question. Yeah, cool. We are done with all the medium. Oh, we are not done with, we have left over with some questions, right? So yeah, let's anyhow increment the counter 81. So let's refresh. Oh, 82. We forgot to increment for one question, I guess. 82. Cool. So yeah, so let's go to the next. I think we're done with medium. We are left over with some medium questions, and those are this. Oh, did we miss this one? Okay, get this one. 1 2 3 4. Okay, 4 medium questions are left over. Let's get back to them at the end. So the next section is the hard section. Let's go to the hard questions. Okay, the actual complexity starts now. The hard questions, I'll filter it based on the acceptance. Yeah, so let's take the first 4 questions. Queens. Okay, n queens. N queens puzzle is a problem of placing n queens on any 2 chessboard. Can design and return out distinct solutions of n queens. Okay, this is a standard backtracking question. Make sure we don't place a queen which attacks another queen. So yeah, this is a backtracking one. So yeah, this is, of course, it deserves to be in hard, but once you solve this, it's pretty much very easy to solve again. So let's start this. So basically, I'll start from the first index and go to the next row, like a DFS. So for seeing if it contains in the row or not, I'll use 2 arrays for that. So first thing, int n, int row, int column. So now I'll assign values in this dot n is gonna be n, row is gonna be new int n, and call is gonna be new int n. So we want a board, right? So for that, a board, I'll maintain a boolean board, new boolean of size n. So I'll call a dfs method. I don't know what are the parameters, but get the answer is of type list of list answer. So answer is going to be new array list, so at the end return answer. So I just said I'll be using a dfs method. So void dfs, I need a row, I need n, I need the board is of type boolean, so boolean board. So yeah, so base case would be if we have reached the bottom row of the all the rows, then that actually means we have placed all the queens. So if r is greater than or equal to n, then we are done with placing. So our solution will be in this board, so we have to basically convert it to a string. So I'll use a method for that, like add to answer or maybe like that. So board, so and return from there. Or else for int c is equal to 0, c is less than n and c plus plus, I'll see if it's not there in this row, if not row of r and not there in this column, and most importantly diagonals, not diagonal of r comma c comma board. Then if this satisfies, I'll add to the row as true, I'll add to the column as true, and the board as well, and board is going to be board of r comma c is going to be true. And now I'll go to the next row, dfs r plus 1 and the board. When we are done with the bottom, when you're done with the bottom rows, we come back to the same row and same cell again, right? So in this case I have to backtrack, I have to make it as false again. False, column of c is going to be false, board of r comma c is going to be false. And now this will take care of everything. So now we have to implement this diagonal method, which is the main case for this. So it's a boolean basically, diagonal. It's gonna take r and c, int r int c. A board is of type boolean board. So int I is gonna be r, int j is gonna be c. So what I'll be doing is I'll see the top left and the top right, because we haven't gone to the bottom left and bottom right, so all we have to take care is just top. So while I is greater than or equal to 0 and j is greater than or equal to 0, I'm trying to see the top left ones. So now if board of I comma j is true in any case, it actually means it is not valid to put a queen in this cell. So return false, true, it is there. So now else always return I minus minus, go I minus minus and j minus minus. Similarly the top right, so I becomes r, j becomes c, while I is greater than or equal to 0 and j is less than n. What I'm gonna do is similarly board of I comma j, this is the case, return true, or else I minus minus j plus plus, or else return at the end false. And we also forgot to implement this add to answer method, word add to answer. So it's gonna add, we're gonna add the board, right? It's the board, it's going to pass the board as well for us, boolean board. So we have to convert it to a string, basically a list of strings. So over int I is equal to 0, I is less than n, I plus plus, for int j is equal to 0, j is less than n, j plus plus. If board of I comma j, if it is true, then I'll use a string for that. So a string row, it's gonna be empty string. So board of I comma j, so row plus is equal to, it's gonna be queen if it is true. Else row plus is equal to a dot. And then we have to add as a list, right? So list, it's gonna be a string int, like a result new array list. So we're gonna add it to result dot add row, return, I mean not return, answer dot add result. I think yeah, this is pretty much, we have to call this method as well. DFS initially 0 and a board. Yeah, I think this works. This is good. This works. This is an easy hard question. Okay, row. Okay, if not row of R, bad operand. Why is it bad operand? Okay, we have created an int. Seems like yeah, it should be a boolean. Boolean. So here as well, boolean. Here as well, boolean. Let's try to run this. Yeah, it got accepted. Okay, let's run this again. Yeah, let's try to submit this. Cool, we are done with one hard question finally. Let's go to the next question. Trapping rainwater. Given n non-negative integers repeating an elevation map where width of each bar is 1, compute how much water it can trap after raining. So it's asking us to find the water it can trap in this bars. Basically, if I take this cell, the trapping water, it's gonna be the left one. This is okay. We have to find the left maximum and the right maximum and find the mean and decrement it by this. So this guy is 0. Okay, I think I have done this question before, I guess. For each cell, I can do a brute force approach. Like for each cell, I can see the left and right max, traverse to the left and the right, and get the minimum of them, and that's a formula. So, but I can keep track of that initially as well. Like, let's do one thing. Let's keep track of that. So initially, it's gonna be height of. This is a big array, man. I think this let's start implementing. Let's int left is gonna be new int of height dot length, or let's do one thing. Let's make it as height dot length. So it's gonna be of length n. Int right is gonna be new int of n. So the left of 0 is gonna be height of 0. So starting from the first index is less than n I plus plus, left of I is going to be math dot max of left of I minus 1 comma height of I. Similarly for the right of 0, I mean n minus 1 is going to be height of n minus 1, where int I is equal to n minus 2, I is equal to equal 0, I minus right of I is going to be math dot max of right of I plus 1 height of I. So then now the formula begins. So int I is equal to I is less than I plus plus. So I'm gonna create an answer, right? The max one. Int answer is gonna be 0 initially. So answer plus is equal to math dot min, right? Math dot min of left of I, right of I, minus height of I, and return answer. I think this works. Let's try to run this. Oh yeah, let's submit this. Cool, it worked. I think we forgot to increment the point counter, but let's do at the end. Reverse nodes in K group. So this is also like a 2-pointer approach. So what I can do is I can use 2 pointers, like from here till K. First one pointer will be at the first, the other pointer will be at the kth node, and reverse that and add to the answer, and again move the pointers K times. And yeah, I think that works. I think we have done this similar question before as well. Like I think it's doing the easy questions, I guess. I think yeah, doing the easy questions. But yeah, I think that's the approach. So I'll be using a dummy list node of unknown value. So now I'll use a pointer which is pointing to dummy at the beginning. So I'll use 2 pointers as I said before. Left is gonna be head, and right is gonna be head as well. So now I have to move this right pointer K times. So as it is already in the head, I have to move this in time is gonna be K minus 1. So while time minus 1 is greater than 0, right is gonna be right dot next. So now while right is not equal to null, what I'm doing is I have to keep track of that right one. So list node right side next is gonna be right dot next, and first thing is I have to remove a connection. So right dot next is gonna be null, and reverse from the left to right. So it's gonna be list node reversed is gonna be reverse from the left to right. So it's gonna reverse the left node. So now ptr dot next will become the reversed list, or yeah, or you can put as a right as well, right, and ptr will become left because it is reversed now. So now left becomes right next, and right becomes right next, and times we have to increment this K times. I mean time is gonna be K minus 1. So in this case yeah, K minus 1. So same things. So time minus 1 is greater than 0, and also right is not equal to null as well. So this satisfies right will be moving these times, and at the end we are done with everything. We'll be left over with something, right? So in this case we are left with 5. In this case we are left with 4 and 5. So we have to attach that to the pointer, so that ptr dot next is gonna be left. So because this is not reversed, so left will always be this in this correct position, and return dummy dot next. I guess yeah, this works. I should run this. Okay, nice. Okay, we forgot to implement this reverse implementation. So we know how to reverse a linked list, right? We have done that before. So reverse list node head. So you know how to reverse. So we're gonna use some pointers. Next is gonna be null. List node prev is gonna be null. So while head is not equal to null, what we're gonna do is next is gonna be head dot next. Head dot next is gonna be prev. Prev is gonna be head. Prev is gonna be head, and head is gonna be next. And at the end, we're gonna make head is gonna prev and return head. I think this works for sure. Let's see. Yeah, cool. Let's try to submit this. Cool, it worked. So we're almost done with. Wait, how many questions? I don't know. Let's count it later. Let's go to the next question. Edit distance. So given two strings, word 1 and word 2, return the minimum number of operations required to convert the word 1 to word 2. Okay, insert a character, delete a character, replace a character. So there are multiple ways. Like a recursive approach for sure. Okay, I think this involves a bit DP in this. Got it. So this involves a bit DP. Okay, so might have to use a bottom-up approach. Got it. So might have to use a whiteboard for sure. Whiteboard is required. Let's use a whiteboard. So let's try to take the example horse and rose. So we have horse and we have rose. To convert these two, we require one change. To convert these to this, we require two change. To convert this to this, we require three changes. Similarly, to convert this to this, we require two changes. To convert this to this, we require this one change. Okay, I'm getting the approach. Convert this to this, we require how many changes? HO to RS require two changes. Yeah, two changes. Okay, to convert this to this, we require two changes. To convert this to this, we require OR, RO, two changes. To convert this to this, we require two changes. Okay, I got it. So we are basically trying to get the minimum of the diagonal top and left. Okay, I got it. So int m is gonna be word 1 dot length, int n is gonna be word 2 dot length, and dp array. So dp is gonna be new int. I'm gonna take an extra row and extra column for good. So for the first row, it's going to be I itself. Just int I is equal to 0. I is less than equal to m I plus plus. dp of I comma 0 is going to be I itself. Similarly for the column, int j is equal to 0. J is less than or equal to n j plus plus. dp of 0 comma I is going to j is going to be j. So now the actual thing starts. I is equal to 1, I is less than equal to m, I plus plus. Similarly for the row, j is equal to 1, j is less than or equal to n, j plus plus. So now if word 1 dot caret I minus 1 is equal to word 2 dot caret j minus 1, take from a diagonal. So dp of I comma j is gonna be take from diagonal and add plus 1. I think we don't have to add plus 1, just take from diagonal I minus 1 comma j minus 1. else find the minimum of 3. A comma j is gonna be math min of dp of I minus 1 comma j minus 1 and math dot min of dp of I minus 1 comma j dp of I comma j minus 1 and add plus 1. So yeah, this is I guess return dp of m minus 1 comma n minus 1. I guess this works. Let's try to run this once. Okay, I have to add the parenthesis. Okay, let's try to run now again. Okay, char at. Okay, a syntax error. How many are we left? Okay, just one error. Yeah, let's try to use example test cases as well. Yeah, it worked. Let's try to submit this. Okay, m minus. Okay, this has to be m comma n. Okay, I think now it works. Oh yeah, it worked. Let's go. Okay, let's try to refresh this. How many have we done? I think 86, I guess. Yeah, 86. So 83, 84, 85, 86. Yeah, cool. Let's go to the next 4 questions. Okay, find median of data stream. So median of median is a middle value. I know what is median. So in this case it's 3. In this case it's 2 plus 3 by 2. So this is, we have to find the median. So it's going to return some numbers. We just have to find the median of the data stream. So one way would be, what I'll be doing is, for the median it has to be sorted, right? So for the sorted, what I'll be doing is, whenever I add a number, I'll sort a list and just find the middle ones. If it is even length, I'll add the middle 2 numbers and divide it by 2 and return that. But for each and every call of this, that's going to take a lot of time. So let's see, after 5 to 10 power 4 calls. So in this case, like these critical are the topics. Okay, heaps. Oh yeah, like yeah, I've got the similar, I have got to know the similar approach before. I've done, I guess. So basically we're trying to deal with the middle numbers, right? So what I can do is I can use a hash, not hash, a priority queue. Queue, it stores integers. One is gonna be min heap, one is gonna be a max heap. Integer max heap, new priority queue. So we need a comparator for this, comma b minus a. So what I'm doing is, if I add a number, I'll add it to max heap dot add this num. So now what I'm doing is, for balancing purpose, min heap dot add max heap dot poll. So now if max heap dot size is less than min heap dot size, now max heap dot add min heap dot poll. I think this balances. So coming to median, I'll have to get the number of elements we have, and it's gonna be min heap dot size plus max heap dot size. So if n percentile 2 is equal to 0, if it is even, then get the middle two elements. So for that, return min heap dot peak plus max heap dot peak by 2. I think there has to be a double. So double, else return max heap dot peak. I think this works. Let's sort of run this. Oh yeah, it worked. Let's try to submit. I think I have done this before, like, yeah, it worked. See, let's go to the next question. Merge k sorted list. You're given it is a case or list, each case is sorted. Okay, this is also a heap based question. So heaps helps me in keep track of the minimum ones. So I'll insert all these lists in the heap and will rearrange them based on the minimum value, and I'm gonna get one by one. So what I'll be doing is merging them, right? I have to return. Okay, I'll use a dummy initially. New list node -1 list node ptr is gonna be dummy. So now I'll create a priority queue. Priority queue is gonna be of type list node. Queue is gonna be new priority. Okay. So I'll add them to the queue. So it's gonna be, we have to add a comparator. So let's add an lambda expression. A dot value minus b dot value. So for each list node of list, from list q dot add a list. So now while q dot size is greater than 0, what I'm doing is I'll take the list first. Current is gonna be q dot pull. I'll keep track of the current dot next. Current next is gonna be, come on, current dot next. So now ptr dot next, I also make current dot next as null, removing the connection. So ptr dot next is gonna be current, and ptr is gonna be ptr dot next. Now if current next is not equal to null, q dot add current next. I think this works. At the end, return dummy dot next. I guess this works. Let's try to run this once. Okay, it has to be next. Okay, let's try to run this. Yeah, let's try to use some extra test cases. Okay, again. Okay, null pointer during adding. Okay, there is a case where it's also a null. So if list is not equal to null, then add. I guess now it works. Yeah, let's try to submit this. Yeah, cool, it got accepted. Let's go to the next question. So sliding window maximum. You are given an array of integer nums. There is a sliding window of size k which is moving from left to right. Okay, you can only see the k numbers in the window each time. Okay, so one way is the brute force, finding a maximum for each window of size k and adding to the answer. So other way is, the best way to keep track of a max or min is, as I said before, heaps. So I'm going to use a heap for that. First thing is, I'm going to add n, and I'm going to create an answer array. N. Oh, is not. This won't be of size n. In this case, 1 2 3 4 5 6 7 8. 8 minus 3 was 5 plus 1. Okay, I think it's gonna be 9 minus k plus 1. Yeah, I'll use a pointer for adding as well. So now iterate through this array nums dot length I plus plus. So q dot add um the value nums of I. So if q dot size increases um till k, then what I have to do? um okay, I might have to reject the one which is less than the window size, right? uh I guess I have to keep track of the indices as well. So class node maybe int value int index with that. So I'm gonna create a queue, so a priority queue. So now what I'll be doing is it's gonna take of type node queue new priority queue. So q dot add new node of nums of I with I. So let's create a constructor for that. So int node int value int index this dot value this dot index is going to be index if q dot size is greater than or equal to k. So if it is k, we have to make sure. Okay, let's do a while loop. While q dot size is greater than equal to k and I think not greater than equal to k, let's greater than k, and if q dot peak dot index is less than, for example, if you are at the index 0 1 to 3 3 minus k 0, okay, if less than 3, if you're at index 3, you're at here 3, right, 2 1, if it is less than or equal to I minus k, then q dot pop, or else answer of ptr plus plus is gonna be q dot peak dot value at the end return answer. I guess this works. Let's try to run this once. Okay, q dot poll, sorry, this has to be poll. We are not using a stack, we're using a queue. Okay, comparable. Okay, we have to add a comparator. A comma b, a dot value minus b dot value. So run code. Okay, ptr plus plus, it is going till ln 6. While q dot size is greater than k, we are trying to, if it is not k, okay, this should add if I is greater than or equal to k minus 1. Let's try this now. Okay, we are adding the values only. Okay, this should be a max heap, sorry, b dot value and a dot value. I think now it has to work. Oh yeah, let's use some example test case as well. Oh man, come on, run again. Yeah, let's try to submit this. Cool, it worked. Let's go to the next question. Largest rectangle in histogram. Given an array, integers, history, heights, okay. Return area of largest rectangle in the histogram. Okay, this is like a monotonic stack something. So basically for each one we have to find the max of left. It's like a trapping rainwater kind of thing. The max of right and find the min. That would be the max one. I think in this case, let's see. So 2 and it's 4. Okay, so the minimum is 2. So it's gonna be the length between them and the minimum of heights. Okay, got it. We have to find the length between those any two bars and minimum of heights, and that's gonna be the area. Oh yeah, so got it. So I can use a stack for that, like finding the monotonic the indices. So what I'm gonna do is int heights dot length. So it's gonna be n, right? So I'm gonna take the left. It's gonna be new int of n. Int right is gonna be new int of n. Stack of type which stores integers. New stack. So now, as I said before, I iterate from the left is less than n I plus plus. If stack dot size is greater than 0 is equal to 0, then that actually means we are not done with anything. So for this first index, which is 0, the left max would be just 0 index, right? So the left of I is gonna be 0. Else I'm gonna see in the stack, while if I'm gonna add a first thing push here, which is I, if it is not 0, then I'll be saying size is greater than 0, and I have to remove them till it is greater than or equal to yeah. So if heights of st dot peak dot index, I think we're just drawing index, right? So st peak is greater than or equal to heights of I, then st dot pop. And at the end, if st dot size is equal to 0, just left of I is going to be 0 obviously, else left of I is going to be st dot peak plus 1, the next index of that. So similarly for the right ones as well, you creating a new stack to remove all the elements before, and starting from the right, I is equal to n minus 1, I is greater than or equal to 0, I minus minus. So now if st dot size, similarly size is greater than 0, I mean equal to 0, right of I is going to be 0 obviously. I mean in this case it's n minus 1, else it will do something, and or else st dot push I. So now the same, almost the same, while st dot size is greater than 0 and heights of st dot peak is greater than or equal to heights of I. This has to be here. If this satisfies st dot pop, so if st dot size is equal to 0 and right of I is gonna be n minus 1, the last index, else right of I is gonna be st dot peak. For the right it has to be minus 1, right? Yeah, minus 1. So at the end I'll be just doing the formula calculation. So the area for int I is equal to 0, I is less than and I plus plus. So left is gonna be the left of I, right is gonna be right of I. So to find the length is gonna be right of I minus left of I plus 1, and the breadth is gonna be length is that, breadth is gonna be math dot, I think it's gonna be the minimum height, right? I think this height only, so it's gonna be the heights of I, the current height. So now answer is gonna be math dot max of answer and length star breadth, return answer at the end. So int answer is gonna be 0. So I think this is pretty much the implementation. Let's try to run this once. Height of I, heights of I. Oh yeah, let's use some extra test cases. Cool, let's try to submit this. Cool, it worked. Let's try to refresh. I think we forgot to increment the counter, but let's see. Okay, 90 questions, so increment 4 times. 8, 9, 10. Okay, 90 questions. So now how many are we left with hard? 1, 2, 3, 4, 5, 6. 6 hard questions left over. So let's go with 4. 1, 2, 3, 4. Okay, given two strings s and t of length m and n respectively, return the minimum window substring of such that. Okay, include the window. If there is no such substring, return the empty. Okay, this is basically keeping track of the characters by using a map and basically doing a sliding window. Man, not again the sliding window. Obviously, brute force won't work in this case, so we have no other option, which is doing sliding window. Okay, so as I said, I'll be using a map, right? So I'll keep track of the characters in this map, and I can do like this. So a hash map which stores the character and integer its frequencies. So I'll use two maps, s map, new hash map. Similarly, I'm gonna use another map for the string t. Gonna be t map. So now I'll store the characters in the t char c t dot to array t map dot put c t map dot get or default t with 0 plus 1. So the sliding window starts now. Int I is 0, int j is 0. I need the answer string, right? So for that string, answer is going to be empty string initially. So now while j is less than s dot length, I have to see if it is there in the t or not, right? So I'll first take the character s dot char j. So if t map dot contains key of c, then I have to add it to the s map dot put c s map dot get or default s map dot get or default c comma 0 plus 1. So now if s map dot get c is equal to t map dot get, I think this should be less than. So I have to increment. Okay, I'm using a counter for that to keep check up the lengths are equal or not. Int count is gonna be 0. If tmap dot get c count plus plus, if they are greater than, then we don't have to exceed. If this satisfies count plus plus, so count, if count becomes t dot length by any chance in some case, then it's time to decrement the sliding window. So now decrementing the I, right? So while I is less than s dot length and count is equal to t dot length, if this satisfies, so now I have to see if answer dot length, we have to find the minimum, right? So if answer dot length is equal to 0 or answer dot length is greater than j minus I plus 1. So in this case, answer is going to be a dot substring from I to j plus 1. And now we have to remove from the map, right? So char d is going to be a dot caret I. So now if tmap dot contains key of this d, then we have to decrement the count. So also take it from the smap dot put d smap dot get d minus 1. So by any chance if that becomes 0 after decrementing, dot get d, then remove it from the map. So now if at all if of decrementing, if the value decreases or if the map size decreases, if smap dot size is less than tmap dot size, or maybe I can use like this, is not equal to, or smap dot get d is less than tmap dot tmap get d, then decrement the count. So yeah, I think this works. And also incrementing the counters I plus plus. So where is the loop starting? Oh, this is this if, right? So increment I here, and where is this loop starting, ending? Okay, increment j here, and at the end return answer. I think this has to work. Let's try to run this. Okay, interesting. Okay, dp smap dot get. Okay, are we adding it any place? We are adding it here. We are adding it here, obviously, and we're taking only if it is equal to c. Okay, count increasing. We are taking the d. Okay, we have to take from I only. Okay, tmap dot contains d. Okay, well, I don't have to close this here. This should be closing at here after this. Okay, I think yeah, this is it. You should go here. I think this works. Let's try to run again. Okay, missing return end of. Okay, one bracket is missing. This is no, this is a complex thing to balance a bracket. Okay, let's start from the top. I don't require this, I guess. This is taking this. Okay, I think now it works. Let's just submit. I mean, run this. Okay, again the same issue. something is wrong with these brackets, I guess. Hmm. If this answer, yeah, I'm tired, man. This is for this, this is for this, and this is for this, and yeah, this works fine, but where are we missing? It's becoming null, right? Null at this place. We are not adding this d anywhere. I think so we're getting it the answer from here. Substring, okay, contains d, then smap dot put. Okay, this should be like this. And yeah, I think now it works. Why did we remove that previously? Okay, I think now it has to work, but one bracket has to add at some place. Yeah, see, this is for this, this is for this is for this, and this is for this. Add an extra one, I guess. Let's try to run again. Okay, somewhere the loop went. I messed up with these pointers. Let's try to intend it again. Okay, intend it again. So answer dot length, we don't need this extra one here. Let's try to run once. Oh my god, finally worked. Let's run again. Yeah, let's try to submit this. It worked. Let's go to next question. Let's increment our counter. Okay, binary tree maximum path sum. Path in a binary tree is sequence of nodes. Okay, I know what is a path. Okay, path sum. It most ones. Given the rotor binary tree maximum path sum. So path can be like this: 1, 2, 3. Okay, path sum. Got it. The path can be like a like this, or maybe a single branch, or like this. Okay, I can do like a diameter kind of approach. So in DFS node root, if root is equal to null, then its sum is 0. So or else I'll get the left ones. DFS root dot left int right is gonna be DFS root dot right. So now I'll use an answer variable. We are trying to do it with some maximum, right? So for that I'm gonna take minimum. So answer obviously gonna be is gonna be math dot max of answer with left plus root dot value, and answer is gonna be math dot max of answer right plus root dot value. Answer is gonna be math dot max of answer left plus right plus root dot value, or answer is gonna be math dot max of answer root dot value. I guess these are the cases, and at the end return math dot max max of, come on, left comma right plus root dot value, I guess. Yeah, I think this works. Let's return dfs root. This has to work. Let's see. Okay, capital case. Yeah, run again. Okay, run again. Okay, went wrong somewhere. It should expect 6. In this case, left is 0, right is 0. 2, 2, 2, 2. It's 2. We have returned. Oh, left, right, max is just 2, so return 2. And in this case, it's going to return 3. So the left, okay, I have to return answer, sorry. I have to return answer. So this is it, I guess. Yeah, let's try to use some extra test cases. Come on, again. Yeah, it will. Let's submit this. Okay, interesting. It failed. I think if it is 0, null, returning 0. Okay, we're returning the left and max of left plus left of right, left and right plus root that value. Obviously we have to return that. Then why? Let's see. In this case is working anyway, and this case also working, but getting the left plus root dot value, right plus root dot value, root dot value plus, okay, and root dot left plus, okay. There might be a case we have to return the root value as well. Got it. So this is gonna be math dot max of root dot value, and the other value is gonna be plus root dot value right root dot value. I guess this works. Let's try to run this. Okay, bracket. Let's try to run again. Okay, cool. Let's try to submit this. Oh my god, finally it worked. Cool, let's go to the next question. Okay, deleting. Okay, first missing let's increment the counter first. 92. First missing positive. So given an unsorted array called as nums, and return the smallest missing positive integer. Okay, you must implement. Okay, I'm not in a stage to follow follow-ups right now, so I'll use the normal approach using a hash set. So this using with a space, we can, it's an easy question. So hash set, so integer set is gonna be new hash set. So I'll use a set, and starting from the 0, from the first the first index, I is less than nums dot length I plus plus, I'll add to the set dot add the nums of I. So now from int I is equal to 1, I is less than or equal to nums dot length I plus plus. If not set dot contains I, then return I, or else return maybe any value, maybe 0. Let's run this. Okay, return spelling mistake. Okay, let's run this. Okay. Okay, let's try to submit this. Okay, mistake. Where it went wrong. If set is 1, if contains only 1, 1. Okay, expected 2. So in this case, I might have to return a nums dot length plus 1. I guess this works. Let's try to submit again. Yeah, it worked. Cool. Let's go to the next question. Median of two sorted arrays. Given two sorted arrays and nums1 and nums2. Okay, return the median of two sorted arrays. Okay, this I'd have done this before, I guess, like just like the median of the data stream question. So I think I can handle this, just dividing the given entire elements into two halves and getting the middle two. So first thing what I'll be doing is I'll keep track of the lengths first. Nums1 dot length. This is a famous question, I know this. 2 dot length. So now I have to start taking the pointers and cut the arrays. Int L is gonna be 0. Int R is gonna be n1. So you can at most makes n1 cuts. Okay, we have to do one thing. So we have to take n1 only for the smallest array. So I'll do that one thing. N2 if nums2 dot length is less than nums1 dot length, return find median of nums2 nums1. This works. So now while L is less than or equal to R, I cut one cut. In cut 1 is gonna be L plus R by 2. The other cut is gonna be n1 plus n2 plus 1 by 2 minus cut 1. I think this is the formula. Yeah, in left one. So this is going to form 4 integers. It's going to cut the I mean the dividing the two arrays. So it's going to be if cut 1 is equal to 0, it's going to be integer dot mean value, or else nums1 of cut 1 minus 1. Int right is going to be if cut 2 is equal to 0, it's going to be integer dot mean value nums2 of cut 2 minus 1. Int right, this is going to be left 1, this is going to be the left 2, this is going to be right 1. So if cut 1 is equal to n1, then integer dot max value, so or else nums1 is going to be cut 1. Similarly right 2, if cut 2 is n2, it's going to be integer dot max value, or else nums of 2 is going to be cut 2. So now it's time to compare. So like the left one should be less than the right two. That's the case, less than or equal to. So if left one is less than or equal to right two, and right right two or right one is greater than or equal to left two, this should satisfy. In this case, now we have got the exact division. Total is going to be n1 plus n2. So now if total percentage 2 is equal to 0, then return, if it is even, return the left, the left side and right side one. So it's going to be return double, right? So double of math dot max of left one and left two plus math dot min of right one and right two and divide by 2. Yeah, else then return math dot max of left one and left two. I think this works. Oh, we are left with some conditions. So else I have to else if. So now it's time to change the cuts. So if left one is greater than right two, so this is the case. Now I have to move R to cut 1 minus 1. Yeah, else it's gonna be L is gonna be cut 1 plus 1. I think this works. This, okay, we forgot a case. Return some value if not found. I think this works. Let's try to run this once. Yeah, cool. I have learned this approach, this question solution in, like in this drivers, like Raj Vikramaditya's channel. Take you forward. So yeah, it worked. Cool. Let's try to increment the counter 93. Let's try to refresh once. How many have we done? Okay, 94. We have to increment for one more time. Okay, let's go to the next questions. We're done with, we are left over with two questions, two hard questions. So let's take this. Yeah, but we're not done yet. We are left over with some medium questions as well. That's the main concern. Okay, longest while parenthesis, given a string and containing just characters, and find out the length of longest valid well formed parenthesis. So in this case it's 2, in this case it's 4. Okay, this is just like a balancing parenthesis. So I can use a stack. So it's gonna be a character st new stack. So I'll use another stack. So character for indexes, new stack. Now I have to find the maximum, right, with the longest length. So it's going to be 0 initially. So for int I is equal to 0, I is less than s dot length I plus plus. So now it's going to be like, I'll take the character dot caret I'll see if C is open, then just push it out, push it in, push C and index dot push I. Yeah, I have to push the index as well. So else, now the main thing starts. So if st dot size is greater than 0, what I'll be doing is I have to remove till the inside one is open one, and st dot peak is equal to open. So now st dot pop and the index as well. This is one combination, I mean one valid one, and find the maximum. Max is going to be math dot max of max I minus index dot peak. Yeah, this works. So or else index dot push I, and the end return max. I guess this works. Let's try to run this. Okay, index dot push I. Okay, we have created a character. It's gonna be of type integer. Run code. Let's try to submit this. I think this works. Okay, empty stack it here. Okay, we might have to add because okay, when we are getting a opening one, we are removing, right? So stack doesn't have anything. Okay, for that I might have to add something -1, maybe like uh -1. So as we're incrementing, right? So we're gonna add -1 at the beginning. So this should be in the index. I think now it works. Yeah, cool. Let's try to increment the counter. The next question, regular expression matching. So okay, given an input string, okay, come on, and S and P patterns. Okay, so implement the regular expression matching. Okay, support. Okay, this is a recursion approach. So if it is a star, either to take it or don't repeat it, or repeat it multiple times. If it is a dot, then we can just move forward. So there are two cases. If it is dot, I can go forward. If it is a star, I cannot take it or take it. Those are the cases. So I think I have learned this question before. Like I've learned this question from Netcode YouTube channel. I think, yeah. So that's the, I think, yeah. So what I'll be doing is, there are two cases. One is dot, one is star, right? So if it is dot, I'll consider the character. If it is not, if it is a star, either consider, don't consider it, or consider it. So those are the cases. This is basically a DP as well. So we have to return true or false. So for that boolean, I'll use TFS method. So int I, int j, string s, string p. So if dp dot contains key of the state would be I plus j here. So let's name it as maybe string state I plus j. So if we have come to this index position state, dp dot return dp dot get this state, or else if I exceeds, or else and j exceeds p dot length, then that's a match. You only exceed if it's a match, right? So return true. If j exceeds, so j obviously exceeds sometimes because j will always be less than or equal to, right? So j is less than or equal to, I mean greater than or equal to p dot length, return false. So now the case starts. If it is a dot, so if I is less than s dot length and s dot caret I is equal to p dot caret j, or p dot caret j is equal to dot, then it's true, right? Boolean, maybe like result something. So if, or else if j plus 1 is less than p dot length and it should be a star, p dot caret j plus 1 is equal to star, So now the main thing starts. So boolean answer is gonna be dfs I comma j plus 2. I won't consider that, or the current characters matches, which is basically this result, and I consider that I plus I and j and s comma p. So dp dot put state with this answer, return answer, or else if it doesn't contain star, if it contains a dot, if match, or if result it matches, so then boolean result is going to be dfs of I plus 1 comma j and or j plus 1, because we have to consider both, right? We move both of them, and s comma p, dp dot put state and result, return and result. I think we have to use answer because we already used result. Answer and answer. At the end, return false, or it doesn't satisfy. I think, yeah, this actually works. Return dfs 00sp. Create a dp map, hash map, string boolean, new hash map. I think this works. Let's try to run this. Yeah, let's try to submit this. Okay, interesting. Okay, state stack overflow error. Why is it stack overflow? Seems like there is no base case in here. Okay, this should be in here because I might exceed and j might exceed, right? Okay, for that I had no other option, so I might have to use a pair method. Or let's do one thing. For this case, let's do here. For here, let's hard code it. I plus j, or this should be inside plus j. I think now it works. Let's copy this test case. Let's try to run this here. Okay, same error. I think there is no base case satisfying here. S dot length, p dot length is a base case. Other base case is j is greater than or equal to p dot length. If dp dot contains I comma, this has to satisfy actually. Stack overflow error, line number 22. Okay, where I j plus 2 result and j, this satisfies as well. Return answer. Okay, obviously we are right. State and answer. I think there's something wrong going on with these concatenations. Let's use the pair method only. Return I plus j. Let's use a pair of I comma j here, even here as well. So it's gonna be pair of I comma j, even here, pair of I comma j. Let's try to run now. Okay, still the same. This time in here, wherever we are adding, it's happening. Why? We are dp dot contains pair of I comma j, return dp dot. Okay, it has to be, but still pair of I comma j. And if I and j is greater than p dot length, return true, and dot length return false, and if I is less than, okay, or p dot cat I is dot. Okay, this should be like this because it's two or conditions, but I feel it doesn't matter. Oh, it mattered. Oh, it's been 6 hours, 6.5 hours. Let's try to submit this. More than 6.5 hours. Finally done with hard questions, man. Let's increment the counter. Let's try to refresh. We're almost done. We are left over with 4 medium questions, and I don't know like I'm gonna complete them or not, but that's okay. 96. We're left over with 2 questions. Okay, 3 are left. Okay, let's see these 3. I don't know, man. I don't know whether I'm gonna do this or not, but let's see. Kth smallest element in the sorted matrix in the n-into-n matrix where each of the rows and columns is sorted. Okay, run the kth smallest element in the matrix. Okay, you can. What is the length? I think this has been added recently, or given an n-into-n matrix where each of the rows return the kth smallest element in the matrix. Let me do one thing. I can use a heap, maybe. I will use a heap of size k. Let's make things faster. Q integer, Q new priority queue. New priority queue. I'm gonna use a max heap. So for int I is equal to 0, I is less than m matrix dot length I plus plus. For int j is equal to 0, j is less than n j plus plus. Let's make it has to be matrix of 0 dot length. So now we have to add q dot add matrix of I comma j. If q dot size is greater than k, obviously q dot pole. At the end, return q dot peak. Won't it work? Okay, it worked. I think this question has been added recently, like. Okay, submit. Or I have missed this question. Yeah, it worked. I think I have missed this question solving before. So these are the leftover questions which we have tried to solve it but didn't get the approach. Which one to start with? Now the nightmare starts. So the last 3 questions. So let's try this. Find all anagrams in a string. So let me read the question again. I think I might forgot. Given to string is return the array of length. Print of start indices of P, you may return. Okay, okay, start indices. Okay, return. Okay, return answer if any order. If we have to return the start indices of these where it's an anagram. Okay, this is definitely a hash map problem, but still the complexity exists. Phew, 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 phew. Okay, hash map obviously. Let's try these questions. Partition equal. I think yeah. In this case, I think we are almost good in this question, but I don't know why we are. Mm-hmm. Let's see. Let's see. Okay, we are getting the total, and we are getting the total and seeing if it is even or not, odd or not. If it is odd, then return false. Taking the half of it. Okay, filling it with -1. So now if index is greater than or equal to num start length, turn. Okay, target should be 0. It is 0, or else if ep of index comma target. Okay, and okay, I don't know I don't know how I wrote this. I might have to start from scratch. Okay, if I don't take that and dfs. Okay, if I take it as false. Okay, terms of index and take will become dfs of nums target minus sums of index. If answer will be take or not take, it is going to be answer of I comes out an answer. Wait, why is it not working? I mean, this seems almost good. Let's try to run again, submit this. Okay, this case is failing. Why? We are creating, okay, boolean length of length n, a dp array of length nums dot length and the total. Oh, this is going wrong in here. Array index out of bound. Index 11 out of length 0. Okay, dp array is not being assigned. dp array length is not being assigned. Why? Um, let's copy this. Uh, this is weird, man. How did it pass now? Okay, got it. In this place, we're not even having total. We're not even calculating the total. So, got it. Now it works. Got it. Yeah, it worked now. That was a small mistake. Like because of that, we have wasted a lot of time before. Okay, we are left with two questions. So this is finding all anagrams. So let's come back there again later. The path sum 3. So this case, what was the question? Given the root and the binary tree. Okay, got it. This was the question earlier. So where it was going wrong? What was the one which failed? Okay, some large values. Okay, one test case is failing. Which one? This is the one. So where it went wrong. I'm using a map. Okay, this is okay. Might have to. What is the answer for this? Two. Seems like some long, long. Let's see it now. I mean, let's see. I mean, it cannot be converted long. Shh. Let's see this now. Okay, it cannot be converted to long. We have to make it to L. Okay, here as well. This is the problem with these data types. Again, L. Okay, where is the int? Okay, sum has to be. Let's put it as long. Okay, let's try to run again. Okay, let's make everything as long. Okay, run again. Okay, got it. So this is the problem. So it was because of the integer value exceeding. So yeah, let's try to run. I mean submit. Yeah, it got succeeded. So it's just small mistake. Because of this we have spent a lot of time. So now I've got that. So yeah, left over with the last question. Oh man, how many have we done? Like it is 99 questions, right? Let's try to refresh. Yeah, 99. So 97, 98, 99. One last question, man. One last question. So come on, let's do this. Like, okay. So I'll first of all take this mess out of here. I don't know what I did there, but yeah. So this is a sliding window. So one question is, I'm just seeing if the brute force works. Did we try brute force before? Yes, right. We did brute force and it didn't work, I guess. Like I'm not sure, but the constraints is 3 into 10 power 4. Okay, these are the constraints, but might work or may not work. I'm just thinking about that. It may not work because we have to sort them every time. It may not work for sure. So definitely sliding window is the only option, man. I'm really tired. I'm really tired to do sliding window right now, but let's finish this last question. So find all anagrams of a string. So let's take this example. Okay, so CBA. Okay, this A is A. This question is similar to that previous question as well. So but there, okay, we have to keep track of the frequencies. The frequencies have to be same, and whenever both the frequencies become same, then in that case we can use that. I can use two maps in here. So one map would be, let's do one thing. Yeah, obviously two maps. So let's use two maps. So the map gonna store the integer, I mean the character, along with its frequency. S map, new hash map, hash map, character, integer, p map is gonna be new hash map. So now the time starts. I mean, just check for checking that. So what I'm doing is starting from the first. So first things first, create a list for writing the answer. New array list. So now if I'm just thinking, if what if the length of this is greater than this? Okay, there might be a case. So in that case, it's empty, right? If p dot length is greater than s dot length, this has to be a parenthesis. Return answer, or else do this. So I have two maps. So first thing, I'll keep track of the frequencies. So what if they are not equal? Let's do one thing. So let's keep track of the frequencies initially. I is less than start length, I plus plus, s map dot put, s dot caret I with s map dot get or default s dot caret I with 0 plus 1. Similarly for int I is less than p dot length I plus plus p map dot put p dot caret I p map dot get or default p dot caret j, I mean I with 0 plus 1. So now I'll see if instead of sorting I can see like this. If okay, let's do one thing. Okay, I can do this only. So I'm just trying to compare both of them. So if I think this doesn't work, man. Let's compare both, like compare s map, t map. If it returns true, then list dot add maybe 0. This is the first case. For the remaining case, for int I is equal to p dot length I is less than s dot length. I think this doesn't work. I'm just thinking, man. I'm just thinking. Do I have to give up for the one last question? I don't know. Like, uh, like my approach, what I'm trying to do is, let me take the whiteboard. So What were the strings? A I mean A C. Let's copy CBA CBA and EBA and BACD. BACD, right? The string is ABC. ABC. So what I was trying to do was I'll add the frequencies of these. C is equal to 1, B is equal to 1, A is equal to 1. So the count is 3 here. So here the count should be less than, should be equal to P dot length. If that satisfies this anagram, I increase. If count is greater than, decrease till it becomes, if decrease till it becomes a I think we have to decrease this till we come to this place. Oh man, I might have to see this solution for sure. Like I might have to give up for this question. Do we don't have any hints as well? Obviously sliding window, I know that. Hash table, obviously I know that, but the approach is getting tricky. Okay, let's try to see something in discussion. So Java using hash map equals method sliding window. So what are I doing? So getting the lens. If okay, we have done this. Okay, we are using a counter array. Taking the frequencies of P length, P array, starting from the S length, taking the letter of S, incrementing the counter of that. If I is greater than P dot length, this letter is okay, got it. So arrays dot equals CA. What is CA? What is CA? Okay, these are arrays. They're comparing the arrays. Okay. Got it. So they're trying to keep track of the count array, and then got it. So oh my god, I'm tired, man. So I don't want to continue with this question because anyhow I saw the solution. But yeah, this is a nice question, to be honest. Like a bit tricky question, but yeah, it's a nice question. So I didn't complete the century, but I'm out at 99, but that's okay. Even Sachin got out at 99 many times, but that's okay. Yeah, so yeah, I think we're done with this. We're done with solving the top 100 Leetcode liked questions. So yeah, so 99 are done. So we're done. We are left over with only one question. But yeah, it was nice challenge, right? So we have got to implement many approaches, many concepts, like many data structures. Yeah, it's been like almost 7 hours, man. I'll try to stop the counter now. Okay, I'll try to stop the timer. Yeah, 7 hours 21 seconds. This is really nice, right? This is really nice. So yeah, so we are done with this. We are done with 99 questions. We have got out at 99. The one which messed up was find all anagrams in a string. This was the question where I got to know the data structures to use and the concept, which is sliding window, but the approach was a bit difficult. That was the case. So yeah, so this is the video. So if you like the video, like I worked really hard for this question, for this, like I've tried to solve. Mainly my focus was to brush up my skills. Like I might have done these questions like some questions from these before, but I just wanted to brush up my skills back, so that's why I thought of taking up these top 100 like Leetcode questions. So that's why, as you have seen, I have done some questions before. I have not done some questions before, but by the end of the day, I've got to know many things. I've got to implement many concepts. Yeah, so if you like the video, please make sure you like and subscribe. Thank you so much. Bye bye.